Okay, sorry about the delay, everybody. I'm sure you're devastated. All right, so can you guys, everybody on? Looks like we got a good amount of people online. Is anybody missing online? Somebody's on by phone. I feel like we're missing one of the female with OUKC people, aren't we? There's only 2 of you, I think, so if I remember right. Does anybody know who's missing? You guys?
She's going to join late.
She's going to join late. Okay.
Actually, she didn't see the mail which you sent her.
Okay.
She, by mistake, she went to the Overland Park campus.
Okay.
And she'll be joining us within half an hour, I guess. Perfect.
Okay, good.
All right.
And how about for here? Who's missing? Who?
Caleb.
Caleb?
Caleb is the lone guy who was in the KCO.
Oh, he's here. Caleb, yes, Caleb, sorry, yes, he's here. Online. Anybody else? Or is that it? Looks like it's about it. Okay. So let's do the same thing we did last time, and I'll open it up for questions. Solar panels. All right. Which question is that? Oh, I gotta hook this gizmo up too. I got a little more hooking up to do.
So I got different tabs on what they got on that problem. Well, I didn't get
Perfect.
Sorry, that was muted before. I don't know how it got unmuted. Good way to keep everybody on their toes. Sorry about that. I don't know how that got unmuted. I didn't do anything.
Yeah.
Hopefully we didn't blow out anybody's eardrums. Okay, what number is the sun one?
5-4.
5-4. Before I do that, let me get the solutions. Yeah, these are suggested solutions, so it's always possible they're not without error. So I didn't write them. I just give them to you because you guys could find it. You could Google them on the internet without any problem. So that's what your critical thinking is about. If you challenge the question, challenge it. So.
I did too.
All right.
But then I was confused because I'm not super comfortable with it yet.
Yeah, that's cool. We'll talk about it.
Is there a way to simplify present value computations over long terms? Or
No.
do you just have to use Excel?
You have to, yeah, you have a way to simplify it. You have to do each time period is calculated separately, and then you add them together.
See, that's what this one was doing, was over 20 years. So either you wrote
Which number is it again?
5-4.
5-4?
Yeah,
that's fine.
All right, here we go. So let me do, I haven't screen shared yet with the rest of the world, so let me do that. Let's see, how can I do that? Here we go, screen share.
Doesn't Microsoft Excel have like a NPV and present value formula that you can use?
I think, well, for sure Excel does. And I'm not so sure Word might not have something like that too, possibly, but for sure Excel does, yes. There's formulas equals PV or PV, and you just put in the variables that you need for it. All right, so 5-4. A university spent $1.8 million to install solar panels atop a parking garage. These panels would have the capacity of 500 kilowatts, have a life expectancy of 20 years, and suppose the discount rate's 10%. If electricity can be purchased for, is it the whole problem or any particular part?
Or it's the whole thing?
Yeah.
If electricity can be purchased for 10 cents per kilowatt hour, How many hours per year will the solar panels have to operate to make this project break even? All right, so suggested answer. There we go. All right, we need that the present value of the electricity generated by the solar panels be equal to the cost. The present value is the 20-year discounted value. Suppose that it operates for 1 hour each of the 20 years, and thus generates 500 kilowatt hours each year. For 1 hour of operation, it generates $50 worth of electricity. All right, and the present value is that calculation. Okay, so what's the question?
How? Go through it.
Go through what, I mean, tell me, I just want to kind of hear what.
Okay, so it says suppose it operates for 1 hour each of each panel only operates once in 1 hour every year. But it adds how long.
So it's got this down into some sort of per hour amount, right? So for 1 hour of operation each year, so it's kind of normalized it sounds like. So for 1 hour of operation, if we can calculate what it is for 1 hour, then if it's 3 billion hours, we just multiply that times 3 billion, right? So I think that's what they're doing here is they just brought it down to 1 kilowatt hour. So for 1 hour of operation each year, it generates $50 worth of electricity. And so we want to think about if I was to get $50 for the next 20 years, what's that worth to me? That's really all we're asking.
But how did we even get to that?
Yeah, how do we do
What,
that?
I mean, if you look at the problem, it's talking about kilowatts, but then it doesn't say anything about kilowatt hours until later. It's like you need an electrical engineering degree to get this problem.
Well, first of all, depending on how you worded it, you could work with the problem different ways. So if you guys came up with different numbers, I think the author chose to use it as this per hour amount. And then, like I said, if it was 500 hours, then it's 500 times that, right? Because it's on a per hour unit basis, so it doesn't really matter.
But how are we using present value instead of the contribution cost? When we talk about break-even calculations, we've got, what is it? Price equals fixed cost divided by quantity plus marginal cost, or you can do it different ways. So this one we're talking about quantity, so it's quantity equals fixed cost.
Okay, let me time you out for a second. So if you're trying to make a decision, how do I decide if I make that decision? Should I step to the right or should I not step to the right? What goes into that decision?
That's an excellent decision which requires marginal analysis.
Okay, good. Which is what? No, let's not go there yet. I want to keep it real simple. So I'm deciding, should I step to the right or should I not step to the right? That's all I'm saying. Step to the right or don't step to the right. Good. Okay, and revenue can be more broadly defined as benefit, right? Marginal benefit. So I want to think to myself, what is all the benefits of stepping to the right? And just try to identify what the benefits are. Ignore the costs, ignore markups, whatever. What are the benefits of me stepping to the right? And then separately, I'll think about what are the costs of me stepping to the right? What's the cost of that step to the right? And then as you correctly stated, if the benefits of stepping to the right are bigger than the cost of stepping to the right, step to the right. If not, don't. That's it. That's marginal analysis. That's the concept. So here with this problem, it says that for 1 hour of operation each year, it generates $50 worth of electricity. Is that a revenue or a cost? That's a revenue. So it generates money to the tune of $50. So that is our marginal revenue. Now we've got a problem with timing. $50 a year from now is worth more than $50 2 years from now. And so I'm going to apply the time value of money on top of that marginal benefit stream, the revenue stream, the $50, right? Because it's 50 1 year, 52 years, 53 years, 54 years. It's 50 over 20 years. And we have a way to do that, falls more into finance class technically, is to calculate the numbers on that. It's econ class right here when we think about, well, what's the appropriate discount rate? What's the appropriate number? I'd say that gets a little closer to econ class when we talk about that, because we talked about whether Samantha should be lending to Sam or vice versa, right? And that depends on whether who's got the higher discount rate. If Samantha thinks she can earn 15% with anything she touches, and the best Sam can do is 10%, then those two discount rates are different. And so the discount rate that Sam puts into this equation would be different than the discount rate Samantha puts into this equation, right? So that's the econ part of it, is really applying it specifically to that problem. Once we get that discount rate established, then it's all a formula. Then it's back to that time value, present value of money. I've got $50 coming in every year for the next 20 years. The appropriate way to handle each one of those streams of flows is to divide it by 1 plus the interest rate raised to the number of time periods that it's out. So in this case, it's raised to the 1 power. We usually don't write that because you don't need to. It's equal to itself. And then to the 2 plus the 3 all the way out to the 20. You have to calculate, I think Kevin maybe asked this earlier, is there any way to simplify this? The answer is no. You pretty much have to do each calculation separately. You add them all up, and that number should be $468.25. So let me pause there for a second. Any questions? Okay. Does that sound all right online so far?
Yep.
Yep.
All right. So now that's my stepping to the right. What are the benefits of stepping to the right? The benefits of stepping to the right are $468 on a per hour basis. And so now we can start looking at the costs, which they have tied into here. How many hours they're doing a break-even analysis here of some sort, right? Yeah. So if it costs you $1.8 million to build the plant, how many hours would it take to break even on that plant? I'm going to make $468.25 per hour. If it costs me $1.8 million, all I'm doing is I'm saying I'd have to be running this plant at least 3,844 hours to break even. Hopefully I'm going to make money. So if I run it for 4,000 hours, I'm making money, right? That's what it takes to break even, because the 1.8 million was a fixed cost. And so we didn't have additional cost on top of that. If I don't have the problem in front of me, but I think that's the way this one laid out. Okay, so that's kind of a synopsis of part A. So let me just open the floor again to questions. Kevin, you still had some?
Well, what we're looking at here is the solution. How do you get that from the problem? Look at the problem. I don't see how they made the connections from the problem to the solution. Because the way the problem is worded.
Well, the good part is you have both. So a university spent $1.8 million to install solar panels atop a parking garage. These panels will have a capacity of 500 kilowatt. That's probably supposed to be 500 kilowatt hours or something, I suppose. But have a life expectancy of 20 years, and suppose the discount rate is 10%. If the electricity can be purchased for 10 cents a kilowatt hour, how many hours per year will the solar panels have to operate to make this project break even? So here we've got the 10 cents per kilowatt hour. Is that did they tie that into the?
Yeah, because that's how you get the $50 per hour. But I was confused because it didn't say kilowatt hours for the capacity of 500.
Yeah.
So I would try to convert that into hours and cents.
It's really the price. price, not the cost. I think they were a little loose with this cost language, the way they say that, because we say that, right? Well, what did that drink cost you tonight, Taryn? You know, we kind of say cost and price, but here they're really talking about the price, the sale price of the kilowatts.
Well, then that makes
But again, that's what your critical thinking. That's what I want you guys to do. You're supposed to dig into these problems. You can kind of, you know, take it a little bit different direction and make your interpretation and dig in. So that's okay.
Even the number that they found as far as the present value didn't match what I came up with on Excel. And it took me 2 hours to figure out that they were doing it at the beginning of the year instead of the end of the year.
Yeah, so they got the first one in at the beginning of the year.
The
So
number
they,
that it came up with in the solution was at the beginning of the year.
with the first year, like, was right in your hand immediately on day one.
Yeah, the biggest difference is the numbers they computed, that 468 is not right, it's 425. I kind of altered their calculation.
Yeah.
But the numbers are transversed, and so when I computed them, it got some totally different. I
Yeah.
ended up getting somewhere around 4.
So what an awesome thing to put in your critical thinking, by the way, is if you come up with that, the author calculated this at the beginning of the year, I think it was more appropriate to put it at the end of the year, something like that. I mean, you can show the two changes in calculations. Yeah.
So, and then I was confused about how you know if it's efficient or not. Because the way it was worded, it said it was not efficient enough
Uh-huh.
for 2,400 hours or whatever. And ours is gonna run like almost double that for 3,844 hours.
Right. So, and I think that's what they're saying here is would, if efficient systems operate at 2,400 a year, would the project break even?
But it's no, because it's not exactly 2,400.
Right.
But if it's more efficient, that's good.
What it's saying is that it needed more hours to be, so like, the system that you were gonna be using wasn't gonna be up to standard with what you needed.
Yeah.
Is what we were finding what you needed.
Yeah.
Yeah.
It'd be running at excess. It would be running too hard, basically, is what I think is what they were getting at there. Yeah. All right. Is that what that's kind of played into part C as well?
Yeah.
Yeah.
So, Les, I have a question.
Yes.
So can we assume that solar panel installation project can work for 5 years or less than 10 years?
Can you say that again? Can you assume that it was 10 years? You mean like in your critical thinking or something?
Mm-hmm.
Sure, yeah, I mean, you could take a variation on the problem. What I'd like you to see you do is, if you do a variation, especially on a problem like this, you might want to explain what the current answer is as best as possible, and then maybe point out an error that they made or some variation on it, and then do something different. Yes.
Thank you.
Yep.
Just that the efficient system operates for 2,400 hours per year. With the project that you, yes, they're using some point.
No, the break even we calculated.
That's 30.
So breaking even financially at the 3844. So that's running a lot. Yeah. That's running a lot more than the 2,400. All right. Anything else on that one?
Well, and then I was confused about the financing part of it, like the grant. Because in the suggested answer, it says a grant of $676,000 would make it worthwhile.
Uh-huh.
And then it goes on to say, in fact, the grant was for the whole 1.8 million.
Yeah, I think that was probably some sort of government plan to support solar that made it worthwhile.
Like an outside source.
Yeah, that's right. That was just a outside commentary that this was from the real world. And this guy, what I like about this textbook is he does tend to use real world stories of things that actually happen. So yes, that's what that was.
Oh my God.
So, you know, if you guys want to get a little philosophical, the question would be, you know, should the government be subsidizing a solar operation to encourage this, even though this is the way the numbers shake out? Because like I said, this was a real world example. And so in order to make this thing work, the government needs to subsidize solar energy. You know, should that be going on? Is that a good thing when people are high on solar and wind power? Same thing for wind, by the way. It's a very similar story. What's the let me back off on that a second and just say, what's the advantage of not subsidizing them? What does it do?
What would drive people to do more research to make it more efficient?
Okay.
More competition.
Go ahead, Debbie.
Promotes competition. They're not. If you're not funded, you're going to work a little harder to make your product better.
Yeah. Yeah. So I think without the funding there, would solar completely die off? You know, probably not. There's probably those, you know, researcher scientist people. They might not even be business people that are like, we got to figure out a way to make this work, you know. And I realize that it's got to work for business. And so by having government subsidies in place in the market system, it takes away resources from other places. So people who might be finding, let me just say coal, finding cleaner ways to make coal, might choose to just go do the solar because there's free government money over there and it'll be a little easier to just work with solar, right? And then there's grant money available for that operation. So again, from a society standpoint, we see a reallocation of resources towards a loser from a potential winner, right? Now, the argument would be made, which is potentially a valid one, that coal and oil are polluting the atmosphere and the temperature is going to rise 300 years from now by at least a degree, and that's bad, and so we got to stop that now and be thinking about 300 years from now. That's part of the argument there, is that it might work now, the dollars and cents might work now for the next 20 to 30 years, but we got to be thinking about our children and our grandchildren and the world being a sustainable place. And so that's where the debate is with some of the environmental stuff. And then you'll get scientists on both sides that say climate change is a bunch of BS and that we're going through a normal cycle. If you look back through 200 years of history on global warming, you'll have other scientists that say something different. And the politicians, in the meantime, in the political marketplace, will be glomming on to whatever rhetoric gets them votes, right? And that happens to maybe somewhat align with their worldview. And then we'll fall into that human bias. We talked about behavioral economics a little bit last time, that behavioral bias where you'll stop looking for information once you find the thing that agrees with you, right? You guys have done that. You're like, oh yeah, I told you, this scientist over here said that global warming was bad, and so then you stop looking. And it turns out there's still a mountain of information that might contest that, but you don't care. And so politicians play that because they're following their own incentives to try to get elected. And if they think that the votes are, then they might choose to, you know, stay with that camp. The economist, in the meantime, attempts, and I'd say economists are pretty good at this actually, let's look to the data. Let's not let our hearts, our little hearts in here that we loved and that tug us in different directions, let's not let our hearts direct policy. Let's do some analysis of the statistics and where we hopefully an efficient job at analyzing the present value of all the marginal benefits and the present value of all the marginal costs on making that policy decision on which way we go. Okay, so that was a little bit soapboxy, but so be it. Anything else on this problem?
Maybe not directly applies to this problem, but kind of came up and one of the other ones aren't working. So as far as when we're looking at marginal benefits versus marginal costs, can that be highly subjective based on the person? Because what you value, what that, you know, what your cost versus benefits are, can be based on your perspective.
Depends on the situation. So some situations would have more subjective element to it than others. So it really depends on the case. But the answer is yes, it can be very personal. And remember when I broke up total cost into explicit cost plus implicit cost? And so yes, the valuation on those implicit costs, which is the economic art that I was talking about, can be more subjective. Now, it's not completely subjective though. So I brought up the expert witness stuff with estimating the value, the economic value of a person who stays at home that got killed, right? To estimate the value of their contribution to the family. And so, you know, was it $10,000 a year, or was it $20,000 a year? The economists might give a range, but at least we know, well, she was worth $1 million to me, right? Subjectively, and we kind of look to say, well, in reality, yes, it's not $1 million, it's actually infinite is what you're talking about, that infinite love thing, right? But for monetary purposes, her income stream and this and that could be replaced with a reasonable range, right? And that's where it's subjective a little bit, depending on the assumptions you make. And then that will be presented to a judge, and the economist might be on some sort of range or something, and the judge might give whatever they think is right, which might be a little more heart-driven after they've given the facts, statistics. Okay. Any other questions on the homework? Other problems you want to work through? And I might mention that you guys who are on Zoom, and this goes for you guys too later when you're on Zoom if you want, you're able to share your screen also. So if you had something that you wanted to, that you wrote down or that's somehow in a digital version, you can share your screen with the whole class too. Like, here's my homework problem, this is how I worked it out, you know, and you could share that with everybody too. Okay, anything else on the problems? So we're gonna have a little test next week at the beginning of class. Another thing that's still a little bit in the hopper is the timing of class next week. So I had originally scheduled it for Thursday because I'm going to be out of town. But the dean of the business school, my boss, told me that we might be having a business school workshop thing that I don't know if I can get out of. Is this being recorded? Oh, it is. Sorry. So honestly, I'd just prefer to keep it Thursday as planned. But if he tells me we need to move class, then we might need to modify that, which would only leave us really Friday. And then I guess we could try potentially or something a Saturday morning. So does that, I know that's not the best news. And by the way, so this is, I don't know if this is going to happen or not, but I thought it would be good to cover it tonight. Would people prefer a Saturday morning or a Friday, the normal time, kind of do Friday night?
What if you have zero access to internet while you're gone next weekend?
You talking about you? Well, then, I mean, you'll just miss class.
Okay.
And then you'll have to watch. Well, I'll work with you on that. That'll be separate. Okay. So if you end up missing class, then and I'll set up some alternative arrangements. Just come and speak to me separately. But those of you who could be attending via Zoom or face-to-face, Friday night, or so it'd be the normal time, probably 6 to, although I'm open for other time too, I guess. I think a lot of you are pretty flexible on times, right?
Earlier in the week?
No, because I'm gone. So Yeah, and then, but what I'm saying is like Friday at 3 would probably work off the top of my head, or that's what I mean. I didn't know what your work schedules were, so status quo would be going for 6, but if for some, we have a lot more people, so sometimes the smaller classes we've been able to kind of be creative on. We could do Friday morning at 6 a.m. I used to. All right, so just by the murmurings, I'm guessing Friday night would be better than Saturday morning. I don't see anybody jumping for joy at Saturday morning.
Zoom quiz is email.
Russ, you're saying instead of the Wednesday evening class?
I'm sorry, Debbie, what?
As far as like us online students, is this something that we're supposed to try to attend, or should we plan to do the discussion next week?
I mean, it's okay for you to be on during that time, but it's only going to take probably the first, 15 minutes or so, and then we'll start off. So you could even come late if you wanted. Okay,
it'll depend on if it's during the day or not, because I'll be working.
Yeah,
otherwise, I'll just
send
board.
Debbie, just keep your head up for a separate email to the online students.
Thank you.
So Friday at 9:30.
Yeah, the usual, and then we can go out for beer, I suppose, if we want, or something like that, since it's Friday night. Oh, you work at the bar? Well, maybe we'll go over there. Where do you work at?
Stuart.
Oh, Stuart. All right. All right, so we'll just leave that sit then. I'm hearing Friday, and then we'll just kind of play it by ear from there. And then if you can't make it, let me know ahead of time. All right, well, let's get into talking here about...
Steve, before you start...
I'm sorry, do you have a question?
Before you start, could you please send us a mail, like when you were doing that?
Yes, I'll end up sending an email. Is that what you said?
Uh-huh.
Yeah, I'll be sending it out as soon as I know. Might even come tomorrow. It's up, although the boss is out of town, so I'm not sure what he's gonna do. So.
Okay. Thank you.
All right.
I assume the quiz is going to cover these first 3 weeks and 4 weeks.
No, just the first 2. 1 through 5. 1 through 5. Not open note, but I will let you use one side of a paper, handwritten, typed formulas or something like that if you want. Yep.
What if I don't have a calculator?
5 by 30.
Excuse me?
What if I don't have a calculator? I just have my phone.
I've got calculators, but it's a little simple one. Otherwise, I suggest you buy one. Yep. You can get it by, to go to the dollar store, you can get those simple calculators for, you're not going to be asked to do any present value things that would require an advanced calculator, just a simple calculator at most. So, yeah, so don't freak out on the calculator, but I do not allow phones for that. So have a little calculator.
So this is for sure next Thursday?
Well, that's what I said. It's next class, whenever that, and it's scheduled to be Thursday, but yeah. And then I don't know if you guys saw on the schedule, the following class is Monday, because I'm going to India. So that's on your calendars. Hopefully you all accepted that the schedule was changed early on, so yeah. You got a conflict? Okay. Okay. All right. Why don't you talk with me when we get next week, and we'll work something out.
What's the date of the
Yeah, what about the homework?
What's the date of the what?
data set from Monday? That's the 25th.
26th. No, 25th. I think you're right. 25th.
What about the homework due date if we have a class on like Thursday?
For that day, I'll go back to the Wednesday time frame, because we're going to be back on a Wednesday to Wednesday basis after that. So the Monday date, you won't have it due before that Monday. I'll give you extra time.
Oh, okay.
Okay. All right, let's start talking about some econ here. I might even have to get a golf club out. you're not careful. So this week, our topics bring us into the demand curve, and we'll get into some what the author calls simple pricing. And so this is kind of demand curve basics. And as I mentioned, if you guys have, how many of you ended up, did any of you get a Principles of Microeconomics textbook checked out? You know, it's free at the library is another way to do it. Lots of library, any edition. I mean, you could go any microeconomics textbook from the last 20 years. You could buy on Amazon for $2 or check out of some library. Might be handy for some of this stuff. What's that?
I think I still have yours.
Do you still have mine? That'll work. That'll work. What's that, Jasper? You do too? Dust off the cobwebs somewhere. All right. So we've been. I think we've drawn a couple of these maybe, but we're going to look at it in a little bit more detail. And so the demand curve shows a relationship between what? What is it when we say the demand curve or the demand function, this line basically, what is it showing a relationship between? Price and quantity. Good. And be a little bit more specific on price for me. How much people are willing to spend, right? Because the price that's being charged by the textbook manufacturer for this book is one price, but the demand curve is actually the price someone's willing to pay for various quantities of this good. So the law of demand says that as the price of a good increases, as the price of a good increases, the quantity demanded, which I'll kind of use the notation Q subscript D, so the quantity that consumers want to buy, right? So what quantity? Well, Walmart's got 55 on the shelves. Well, that's the quantity supplied, but what's the quantity that people want to purchase? If we're looking at the demand curve, we're thinking about consumers now, and so we've got the quantities being demanded by households at various prices. The law of demand tells us that as the price of a good increases, the quantity demanded does what? Decreases, right? So price gets higher, people buy less. Now, the law, the way I have it written, is completely wrong. It's completely a lie. It's false. Price goes up, quantity goes down. That's a lie. Can you tell me why? As it's written, I don't really have enough information up there.
That's because when
a situation where as the price goes up, you buy more still. You don't care. Stock, okay, so stock prices are going up and you want to be a part of it, so you buy it?
Yeah.
And why? If it keeps, so what is that decision to buy it based on?
Demand.
Good, future. It's actually more on the future, right? And I think you might have even said this, you expect it to go higher. So with that stock price, you're not obeying this rule because this rule only applies if your expectations are held fixed. In other words, the expectations about the future value are the same today as they are after the price goes up. If we hold your expectations constant, then I would argue this still holds. Potentially. What else is true. Can you think of another example? So stock, that was one maybe. Price goes up, you don't care, you still keep buying. What would cause you to keep buying a product even if the price is going up? Brand loyalty, okay, so and maybe it's in style or something. Go ahead online.
Need.
Was that you, or I thought I heard somebody online? Oh, it was you. Okay, what'd you say?
Need, like medicines.
If it's a need, okay. So yeah, so if you've got a need, and that's going to play more into the. I keep looking up there trying to get my thing to work here.
What about stuff like status?
You know, I think that's kind of similar to brand loyalty, but yes, if something becomes more popular, it starts to have more status, you don't care, you'll still buy it, right? How about your income? Price goes up, but you go to the lottery, to the Casey's and buy a lottery ticket, and you hit the big one. You hit $50,000 pull. Do you care that the price went up? No. Are you still going to go buy it? Doesn't matter, right? So your income changing. So the point with all that is that the most important part of this law is the thing I haven't written on the board yet. And it's a Latin word. Does anybody remember this from principles class? Since we got Kevin and Jasmine on the spot. Jasmine? Ooh, you sound like you were close to saying it even. I thought I was anxious. Ceteris paribus. Ceteris paribus means holding all other things constant. In other words, I'm going to hold constant your expectations. I'm going to hold constant your income. I'm going to hold constant everything. Then we claim that the law of demand holds. Price goes up, people buy less. If one of those things do change, so I want to put ceteris paribus. So let me put a little asterisk by ceteris paribus. All other things constant. Things like income. Things like preferences. You mentioned status stuff, or if something goes in style. So consumer preferences. Things like expectations. Things like price of related goods. Price of peanut butter goes up, but jelly stays the same. You still might buy less jelly, right? Because I use peanut butter and jelly together. Peanut butter is way more expensive. I'm going to eat less sandwiches overall. I'm going to buy less jelly, right? So there's these interconnections of relations that goods have. We're going to hold those constant as well.
Ross?
Yes?
How does income comes over here? Income? Income is not constant, right?
It is for the law of demand here. So we're saying that if we were doing this example for you, we might say, suppose that you're making $30,000 a year. We're going to hold that income constant and now increase the price of peanut butter. How does your purchases of peanut butter change? That answer might differ if we allow your income to go up from $30,000 a year to $40,000 a year. Right? That makes sense?
Yeah.
Okay. All right. So with income, I want to make a couple comments on. Most goods are what we call normal goods. Normal goods. And that means if income goes up, an increase in income leads to an increase in purchases. So you buy more, income goes up, and you buy more of that good. Can anybody give me an example of an inferior good? An inferior good is one in which there's an increase in income and you actually buy less of the good. Ramen noodles, right? The old college student example. So in college, ramen noodles was a staple, and now that you got your first job or you're into your job ways, you don't buy ramen anymore. Or maybe you just buy less of it. You still have that hankering for ramen on a Saturday afternoon maybe, right? Or once in a while, but you're buying substantially less of it, right? So that's an inferior good. So we got ramen noodles here, We got steaks and hamburgers or something up here. So different types of goods fall into those categories possibly. So preferences, you know, something is in style, might cause, if there's a fad, I think as near as I can tell, Pokemon Go has exploded in the last week, or 2 weeks maybe tops, but especially this last week. So all of a sudden, preferences have changed. Your friend's doing it, so you want to do it. Your taste for that good have changed because it's been in the news and everybody's doing it. So, and then I talked about expectations. So this could be the expected future price, which I'll use a little notation later on in the semester of P superscript E. So this is the expected future price. If I'm expecting gas prices to skyrocket next week, what do I do today? Fill them up, right? So I changed my behavior today based on my expectations of what tomorrow's going to bring, right? So in other words, this went out the window. It wasn't anything to do with price today. It was about tomorrow's price that really drove the result. All right, and price of related goods. Goods can be substitutes. So goods can be substitutes. So if there's an increase in the price of Coke, what happens to the quantity of Pepsi? What happens to the quantity of Pepsi? If Coke prices go up, what happens to the quantity of Pepsi sold? It goes up, right? So notice price going up, quantity going up. With substitutes, that's a positive relationship between two goods that are substitutes. This one gets more expensive, I buy more of the substitute. This is going to be real important when we get to next week's material with pricing behavior and bundling of products. Goods can also be complements. Complements, which I already mentioned, an increase in the price of peanut butter. An increase in the price of peanut butter leads to an increase or decrease in the quantity of jelly. Jelly's going to go down, right? So I'm going to buy less jelly because the product I really like is peanut butter and jelly sandwiches. And so if peanut butter is more expensive, it makes my sandwich more expensive. And so I'm going to eat less of those types of sandwiches. I'm going to find other substitutes. All right, so that is a quick rundown of the demand curve. And again, this is where a Principles of Micro textbook, that chapter will cover this in really good detail if you want to review that, much more than what your MBA textbook covers. So a lot of that's kind of, he talks about it in words, but he doesn't do pictures and other stuff. So you get a little bit more detail in that Principles textbook. Okay, all of these things here end up being demand shifters. Demand shifters. All of these things are potentially demand shifters. So if I come over to this demand curve, the demand curve I drew was based on ceteris paribus, holding all of the things constant. Things like what? Things like income, preferences, expectations, price-related goods. Holding all of the things constant, if the price of a good, give me a good, any good. Snickers. If the price of a Snickers bar, what are those running nowadays? Dollars. What'd you say? $1.60. So $1.60 at a price of $1.60 at our little Quickie Mart down the road, we're able to sell well, let's see, if it's just Snickers, we'll just say 10, that's fine. So 10 bars a day. And if we were to run a sale down to, let's make it 60 cents, like one of those crazy, get rid of the inventory sales. At 60 cents, the law of demand says, holding all other things constant, we're going to sell more of them, right? And so we're going to sell maybe double to 20. So there's an increase in the quantity demanded when there's a drop in price from $1 to $1.60. All right. If there's an increase in income, what happens to this demand curve if Snickers are normal goods? If Snickers are normal goods, and there's an increase in income, by the way, holding all of the things constant, if now there's an increase in income, so the average income in Ottawa is, let's say, currently $27,000. And now we have a new industry comes to town, things are booming, a year later, average income rises to $30,000. What happens to this function? What do you think happens if there's more income? Shifts to the right, right? It's going to relocate itself. Now, here's the way I like to do this. You might remember that I said, or did I say this? I think I said this. Thinking about these as a collection of points in two-dimensional space. So that's what I want to do is, let's just take these 2 points. Remember, there's a whole bunch of points, by the way. If the price of Snickers were way up here, people would only buy this much. If prices were here, people would buy this much. If prices were here, people would buy this much. If people were here, they'd buy this much, right? And so now, at a price of 160, I used to want to buy 10 Snickers, but now that income levels are 30,000, I want to buy this much. At 60 cents, I used to want to buy this much, now I want to buy this much. At this price, I used to want to buy this much, now I want to buy this much. At these high prices, I used to want to buy this much, but now that I'm a rich guy, I'm going to buy more. And if we do that an infinite number of times, the dots become so close together that we have a demand curve that has shifted to the right by that amount. The demand curve has relocated itself. Okay, that's true of all of these. So that's what we mean by these are demand shifters. These are our ceteris paribus things. If these things change, it ends up being a shift in demand. All right, questions there? So that's kind of a warmer-upper. There's a little bit of this talked about in this chapter. You know, I might, maybe before I jump into the next thing, I want to talk about consumer surplus, because this is another thing that's mentioned in the chapter. So if you go to the store, and for this one, I don't know if, even know if you guys want to draw this in. Maybe if you just do a dash line, it's okay. But the supply and demand curve, right? If we bring into account the Quickie Mart's situation, which is based on a number of different things, depending on what they believe the market price is, they're going to bring a certain amount of Snickers to the shelves, right? And so we have this equilibrium where there's 10 that are desired and there's 10 being provided by the market. What's not so obvious is the value that the market system brings to those consumers. You guys have felt this before. In fact, who's my Snicker person? You're Samantha. You're the Sam. You guys switched on me, didn't you? I think. No, you didn't? Oh, darn. Okay. So, Sam, when you're really having that Snicker bit, what's the highest price you'd be willing to pay when you really, really want one? You don't have to say $100, but maybe it would be if you're on a desert island. But I'm saying on a normal day during the week and like you're just dying for Snickers, what would you walk away from? What's the highest price? You're like, well, I'm not willing to pay that. I love Snickers, but I'm not willing to pay that. I mean, kind of be honest with me. Kind of tell me what the most you'd be willing to pay on a day where you're really having that Snicker fit. $2.50. Okay, so she comes in, it's $2.50. If it's $2.75, she might think, I don't really need it, right? So $2.50. So my point is that the store doesn't know that. Now I'm going to screw this up again. Sand. The store doesn't know which one's sand, right? So Sam is one of these 10 Snicker bars. And so Sam is this person right here, lo and behold, that was willing to pay $2.50 for that Snickers. Did Sam get a deal that day? Yeah, she paid $1.60. She was willing to pay $2.50. Economists call that consumer surplus. So this is consumer surplus. Consumer surplus, which we'll kind of use shorthand notation of CS.
So that's like the difference between what a product's being sold for versus what a consumer would pay for it.
Yes. The difference between the value that they place on it, and this is where, we've been talking a lot about value and wealth creation, right? So the value somebody has on it is $2.50 out there. And they only had to pay $1.60. So the difference between what they were willing to pay and what they actually pay is consumer surplus. So if you want to think about the demand curve a little bit differently, you can think about it in terms of people's willingness to pay. It's ordered by the value consumers place on it. We don't ever necessarily see this, but think of, Sam's in the number 2 position. Somebody out there was willing to pay $3, right? And somebody out there was willing to pay a little less. So we have this ordering of the units with varying values placed on that product. All we observe from the marketplace, 10 Snickers were sold that day. We don't really know what this is, or do we? Or can we estimate it, right? We know that it exists, and this is where the economists have some fun, is we want to be able to estimate that. What is the sensitivity of people's purchases to prices? Because if they're not real sensitive, like Indu brought up about a need, if we're really addicted to the Snickers, then the company can charge kind of higher prices and still not lose too many sales. So one of the key features here, remember, is that the company would love to jack up their price, but the law of demand reminds them that if they jack it up too high, they lose all their business, right? So these are competing forces for the profit maximizer. What's that profit equation again? Total something, yep, total revenue. Good, total revenue minus total cost. Total revenue is what in its simplest form? Break that formula down for me. Nope, total revenue. Break that down for me. Simple little formula. Not trying to trick you, but I want to prove a point. How do we calculate total money in the cash register that day if we're in the business of selling sodas? Price times quantity, right? It's just P times Q. Now check this out. That's why I wanted to bring you back to this formula, is that this P times Q, now that we take the way the real world works, if the business raises P because they want to make this as big as possible, because don't forget they want to make this as big as possible, right? So there's profit maximization. Underlying profit maximization is to try to raise the price, but they've got a problem. If they raise the price, the law of demand says the quantity is going to fall. These two things are fighting with each other then. Assuming it's a normal good, that's right. With, well, we were on it, no, not assuming normal good, I'm sorry, because I'm just focusing in on prices right now. So this is strictly law of demand. We're holding income constant.
Oh, okay.
Okay? So these two things are competing with each other. I've never actually lectured this way, and I'm kind of liking how this is playing out. So sorry to reveal my excitement. I should be a better poker player. What would cause revenues to climb then? If I raise price, how are my revenues going to be able to climb if I have these two fighting each other? Okay, let's not even worry about cost at this point. How am I going to get my revenues to climb?
Number of, increasing the volume.
I want to be more specific with that formula. So you see my logic where I'm going here is, if I increase price, that's good. Go ahead.
Price has to be increased by more than quantity.
Great.
By increasing marginal profit?
Yes, and we're looking here really at marginal revenue, so not profit. But Nathan, right? Nathan said it correctly. I'm going to paraphrase a little bit, but we need the price effect to be bigger than the quantity effect, right? And how we're going to come back to that is with percentage form. So if I increase my price by 5%, quantity is going to fall. Law of demand told us it is. But if quantity only falls by 3%, I'm in the money, right? The price effect is bigger than the quantity effect. And so my revenues are going to climb. But there's another case where it's possible that the quantity effect is going to be bigger than the price effect. And so if I raise my price by 5% and quantities fall by 10%, that's a losing deal, right? I'm going to lose revenue. All right, that's the concept of the elasticity of demand. The elasticity of demand is a lot of the focus of this chapter. So let me pause there before I write anything on elasticity. Questions?
Going back to the idea of consumer surplus.
Okay.
We talked about a situation where someone's willing to pay more. Can I go in the other direction? So let's say you just really hate peanuts.
Yeah.
You know, and I mean it's got to be that price has got to be pretty low to make you go that line.
Okay, so I think if I'm understanding right, if we take this demand curve, you're driving it to its corner solution, which is right here.
Right.
Which means I could drop the price to 0. But everybody with peanut allergies is still here.
Well, no, I'm not saying an allergy where you can't. I'm saying it's just not your favorite. So it actually puts you below that equilibrium point. This person exists, right? This person is willing to pay 60 cents. The price at the store is $1.60 because I drew the supply curve in here, right? So this was, by the way, this is the market price, but just by assumption the way I drew it. So we're saying that the market price is $1.60. Is this person buying a Snickers? No. So there's no consumer surplus because this person's not buying it. Right, but if you're below
it's called a non-sale because they're not willing to pay for it. Truly. Yeah, you might call them out of the market. I'm out of the market, right? I'm not in because the market price is $1.60. I'm willing to pay 60 cents. I'm out of the market. If you wanted me to put a name on that, that would probably be the closest thing that came to mind. I think you might be the first person in 20 years that's asked me if that has a name. So I might have to give you an extra credit point for that. All right. Any other questions? Out of the market. That's kind of a finance term for in the money or out. Let's see, Jillian. All right, there we go. Got you marked down. Okay, anything else? Other questions or comments? You guys okay online? Give me a thumbs up if I see all right. All right, good. All right, so the elasticity of demand, let's see. I think, I'm trying to decide if I should erase or not. I think I could go right here. Yep, I'm still on the board there. Okay, I got one little section here I'm going to play with. Actually, I probably almost could erase this, but let's just do that. All right, the elasticity of demand, which I'm going to use this little symbol, it's kind of a sigma subscript D, the elasticity of demand, also called the price elasticity or own price. So price elasticity is another word for it.
ED, sorry.
ED, yes, E over here, yes.
You got it.
Not for erectile dysfunction, but for the elasticity of demand. You got it. Okay, so the elasticity of demand is a number that shows the responsiveness of quantity demanded to a given price change. It's a number that shows the responsiveness of quantity demanded to a given price change. Gosh, I hope this groundwork pays off. I'm going to come back to you. Hopefully you guys got this. So, all right, here we go. Here's that number. It is the percentage change in quantity demanded over the percentage change in price. The elasticity of demand, that number that I just defined up here, is simply the ratio of the percentage change in quantity over the percentage change in price. All right, so trying to decide on how much I'm gonna skip a part that I normally do because I don't want to. I'm not going to burden you with another formula. I'm just going to give it to you, even though I kind of like doing that. But so this is hard for me, is what I'm saying right now. It's difficult. Okay, so your book gives you this formula, and I'm going to give you the intuition, but I'm not going to work through all the math for you. Is what I'm going to do. So Q1 minus Q2 over Q1 plus Q2, all divided by
P1 minus P2.
P1 minus P2, good.
Divided by P1 plus P2.
Yes. All right, and I should have drawn this a little bit prettier, but essentially this upper part is this whole part, and the lower part is this whole part. And the math that I'm not going to bore you with, but I'm going to show you, is over here. Let me draw your attention here to this demand curve. What was the percentage change roughly? Again, I'm not even holding you to a formula. Going from 10 to 20, what kind of percentage change is that for quantity? 100, right? It's a doubling, so 100%. Now, how you got that, if you take the percentage change in quantity, it's equal to the new number minus the old number divided by the old number is the normal way to do it for percentage change. New number minus the old number divided by the old number. And so the old number here would be 10. 10 over 10 gives us our 1, which is our 100%, right? So your gut feeling was good, Jillian. You had 100%. Now, if quantity fell from 20 to 10, what sort of percentage change is that? Be careful. New number, 10, minus the old number, 20, divided by the old number, 20, gives us negative 10 over 20, 0.5, 50% negative. Now, that's a problem with estimation because Has the units changed at all? It's still a 10-unit fall either direction, whether I'm going up or down. But the percentage change gives me a different answer. So I'm giving you the really abbreviated version of this formula is true if instead of using the new number or the old number, we use the average of the numbers. So we have a little variation in the formula that we use for the elasticity of demand, where instead of dividing by the 20 or dividing by the 10, we're going to divide by the average of the two, which is always 15. And if we did that, notice that this would be 15, and this would be 15, and we'd have whatever that turned out to be. Okay? And again, I'm trying to give you intuition that at the end of the day, that's the formula, and that's the way it works out. But go ahead, Nathan.
So how is that still the same?
So this, all I'm doing is I'm dividing by the average of the two rather than one or the other. So that a quantity increase or a quantity decrease gives me the same percentage change.
But that doesn't equal 100.
It's not going to equal 100 with the 15. So 10 divided by 15 is 3 threes, got some threes in there. 2 threes, 10 15ths. What's that percentage?
2 by 3, it's like 1.76. Oh,
67 is 2/3, so it's 66%. This one now would be also 66%. And it's negative, yes. So all I'm doing is I'm using the average so that my elasticity number is essentially centered along the 2 points. Okay, that's a long story. I maybe shouldn't have even gone that far. But trust me, I've checked it backwards and forwards, and I'll be happy to sit down with you privately if you want me to show you the proof for it. This formula gives us that. And so it's kind of a funky way of calculating the elasticity of demand. All right, let's get away from the formula junk for a second and get back to the intuition of cocaine versus Snicker bars. Yep, before you go ahead.
Okay, so 10 over 15 essentially is that whole formula, not just.
No, it's just the upper part was all I was looking at, because I was just focusing in on the quantity. And then I'd actually do the same thing up here. The average between these two would be what, $1.10? And I'd use $1.10 to calculate the elasticity here. $1.60 minus 60 is $1 divided by $1.10. And then that's going to be my elasticity of demand for that area of the demand curve. And let me pause your question, any further questions, because I think once I give you the intuition, hopefully that'll help this a little bit rather than hurt it. All right. Let's see. I'm going to draw 2 demand curves side by side. Am I getting too low over here? Maybe I should. I could probably get rid of this junk. Let me give myself a little room. So we're going to draw 2 demand curves side by side with each other. 2 demand curves side by side. But one's going to be kind of flat, and the other one's going to be kind of steep. And then I want to imagine that there's 2 points, P1 and P2. P1 corresponds with Q1. P2 corresponds with Q2. And P1 is going to be $1.20. And P2 is going to be $1. So there's a drop in price going from 1 to 2. That sale price caused quantity decline from 100 to 180. So Q1 equals 100, Q2 equals 180. So calculate the elasticity of demand for me for these numbers. And I don't have this worked out ahead of time, so I'm totally relying on you guys. Here's the formula. You've got the Q1s and the Q2s and P1s, P2, put them in the right format, and first person to get the right answer gets an extra credit point. Go. If you guys are quick online, you might want to unmute your microphone. That's Jeopardy, if anybody knows. I might be dating myself now. Is that show even still on? Yes.
It's Q1 P1 plus Q2. Big number.
On the formula,
Yeah.
it's Q1 minus Q2 divided by Q1 plus Q2.
Yeah.
No answers yet? No answers yet? Come on, you guys. You're disappointing me. Somebody, be brave. 3.11. That's the first answer I heard. Remember, I don't have this worked out ahead of time, so if Samantha's the only one that calculated it and nobody backs her up, she's going to be right, and we're going to continue on with the class. She's going to get her extra credit point, even if she's wrong.
I think it might be negative.
Okay, negative.
Yeah.
All right, I'll allow. Nobody else jumped in there, so I will allow you to make that modification.
No, sir, I can't see the number, sir. It's some glitter.
You got a glare on which did you switch your camera angle to this one?
Yes, of course I do. Like I can't see the number. Like I can just see the 100 minus.
Oh, for Q1?
It's P1 and P2. It's not visible for us.
P1 and P2?
Yeah.
So P1 is $1.20. Sorry to have you guys at a disadvantage. Maybe I'll restart the clock for you guys. P1 is $1.20. P2 is $1. $1.
Negative 3.14.
Negative 3.14. Who said that?
And I got negative 3.16.
Okay. And who is that? Eric?
Harika.
Harika. Okay.
I got 3.14.
We have a confirmation on 3.14. There's a check. Any other confirmations coming in? You need my calculator. Okay. Negative 3.14. So another check. We got 2 checks coming in. Anybody else?
Minus 3.14.
3.14. Okay. All right. So I think we have a winner. Who is our 3.14 again? All right, you're on. So 3.14, we will figure with 3 supporting votes that you've got the right answer, because I honestly don't know what it is. So you guys hopefully got the rest of this worked out. Now, why is it negative? Because there's a negative in the numerator, right? What if we would have went the other direction? If this would have been
Q2 minus Q1.
This one would have been P1 and that one would have been P2. Would it have then been positive?
No, it'll be negative.
So what's the real reason it's negative.
The difference in demand.
Okay, what about the demand?
The difference, like the whatever the number changes in the demand, it's making the main change in elasticity.
Yes, I'd like you to be a little more precise though. If this was a multiple choice question, why is the elasticity of demand negative? Okay, open-ended question. I changed my answer.
Does it have to do with the relationship between price and quantity?
What is that relationship?
One is falling less than the other is rising.
And what is that relationship?
Inverse relationship.
And what do we call that?
I don't know.
Yes, you do. I gave it to you. What? Nope. I like it. You guys are saying all the right things, but it's not the elasticity of demand that drives that negative answer. What's the first thing in your notes today that you're going to?
Law of demand.
Law of demand. Price goes up, quantity goes down. Price goes down, quantity goes up. Right? All of that, what you guys were saying with the inverse and all of that, that's the law of demand. That's the law of demand that's driving that result. So this is due to the law of demand, the negative sign. All right, now here's the confusing part for students that you might see come up. Because we all know it's supposed to be negative, sometimes we just ignore that. And we speak about it as a positive. So we might say, oh yeah, the elasticity is 3.14. The elasticity of demand is 3.14. Because we all know that it's really negative due to the law of demand. So, and I'm being serious, they mostly, I think this evolved in the economics profession just to confuse students, but I can't confirm that. But we usually think of elasticities in terms of its absolute value. So we might remember that from math class days gone by. 2 bars on the side of an expression means that we're thinking about the absolute value of it is 3.14. So sometimes in your homework problems or otherwise, they might say the elasticity of demand was estimated to be 2.5. The price elasticity of demand was equal to be 3.14. But the negative sign is implied there. Okay? All right. So, what if I was to drop it again to 80 cents? So I'm going to drop it by 20 cents again. I told you that this kind of centers up that the elasticity of demand, because of the way we do that formula, here was equal to negative 3.14. If I drop this to 80 cents, what's this number? Assuming this is a straight line. Let's Q3, I guess, if you want.
So elasticity of demand is average.
For not quite an average, we're using the average of the endpoints. It's called an arc estimate because we're taking the average of the 2 prices we're estimating. Where's my mute all? There we are. Mute all. Okay. So remember to mute your.
We can't hear you.
Russ, we can't hear you.
Russ, we cannot hear you. Russ. Russ.
Is that all I needed to do?
Yeah, it's clear. It's clear.
Okay, now we can. I don't know. So, I bet it must have automatically did that somehow. Okay. You guys can all hear me now? All right, good. Okay. So I'm going to drop the price from $1 down to 80 cents. What is this number? Q3. Assuming a linear demand curve. Lindsay? 260. How'd you get that?
It's a combination.
Difference here, and
Yeah.
it's a straight line. So what's true about the slope of the curve? It's constant, right? So we know that this is going to be 260. In other words, drop of 20 gave me a bump of 80. A drop of 20 gave me another bump of 20. So rise over run for the slope. This number is 260. Now, what's the elasticity of demand between Q2 and Q3? Shouldn't it be the same? You would think so, but it's not. So go ahead with your calculators and calculate it out. That's the important thing we're going to try to drive home here, is that it's not going to be the same. And you guys will see this now as you write it out on your paper. You'll see how the numbers change and why that's not going to work out. And then as soon as you get an answer, spit it out. I'll probably got another extra credit point somewhere here in my book. I got my little extra credit pen. Yes?
Russ, we cannot see those numbers over there.
Okay. Let me try to bring this little sucker in closer. Let's see here. There. Can you see it on that camera?
Yeah.
Switch the camera to the, there's a different camera angle if you go to the, a different camera. I have 3 different cameras going, and you can select the screen. If you go to the Brady Bunch screen, there's kind of the little zoom thing. I brought it up nice and close for you over here.
So this equation, I just add in minus Q3 as well as minus.
Yeah, so now you got to change the, yes, we're going from Q2 to Q3. Yes.
What's the Q3 value?
Q3 was 260. I'm not sure if I heard you right.
Yeah, Q3.
23, is that your answer?
No, Q3 value.
Q3 is 260.
Okay.
So Q3 is 260. Who's got an elasticity for me? You guys were all close, by the way. This must have been rounding error. That's as close as I've seen numbers come out. You got negative what this time? 1.64. 1.63. Might have some funky calculators here. Yep, absolute value. I got it. So, anybody else confirm one of those two? 1.64. 164. So I'm kind of hearing 164 maybe. All right, so by the way, this level of rounding is not going to matter for the most part, like even whether it was multiple choice or on a test or something. I'm not going to dock you for that. So so we've got a different number. Which number is more elastic? Go back to your definition. What is it again? Elasticity of demand is a number that shows responsiveness. This number is bigger than this number in absolute value. And that's where we use the absolute value thing too. Which one is showing a bigger response? Which one shows more responsiveness? The 3.14 or the 1.64? 3.14? Why? It's a bigger number. So you have kind of a coin flip. I don't like that. I want more talk behind that. I think I like the answer though. It's more responsive. Why would we say that it's more responsive? How big was the price change in each case, by the way? It was the same, 20 cents, right? So look at this equation and tell me about the number 3.14 being bigger than the number 1.64. What's true about this ratio then? Okay, price and demand, price and quantity demanded, there's a connection here, right? Which one had a bigger quantity effect? The 3 one or the 1 one? Which one had kind of a bigger quantity effect? In terms of, it's really the relationship with the quantity effect, price effect, by the way. So kind of be a little.
1.64, the quantity effect.
The quantity effect, right? Yeah. So what about it? The quantity effect was bigger with which one? The 3 one or the 1 one?
1 1.
The 1 1. I hear a lot of 1 ones. I think we got to go back to thinking about our fraction here. If I'm hearing too many 1 ones, how do I get a bigger number here? This number, a number, this number, this number, or this number, a number that shows the responsiveness of quantity demanded to a given price change, smaller denominator or a bigger numerator at the same time. So that's why I was saying, so which one has a bigger quantity effect relative to the price effect, the 3 or the 1? The 3, right? So this must be bigger than this. So to get a 3 here, 9 divided by 3 is 3, right? So we'd have a 9% change and a 3% change. If I cut price by 3%, that's bad for revenues. But if I sell 9% more product, that's good overall, right? Just right back to that formula that I took you to before, the quantity effect is outweighing the price effect, the two at battle with each other. With the 1.64, in fact, I could do a little trickery. You can always take any number. This is really convenient, by the way. You want to take not so much trickery as good solid logic here. Everybody okay with any number, no matter what it is, divided by 1 equals itself? Cool with that? Remember that little rule? That was way back in 5th grade math. But you can take any number and turn it into a fraction. How? Divided by 1. Well, that's awfully convenient because this formula is a fraction. And now we can even tell a more detailed story about the elasticity. You can tell your boss that you're working for that a 1% increase in price will lead to a 1.64% decrease in quantity demanded. Right? So it kind of lays out the interpretation for the elasticity on that number. So with the 3, a 1% increase in price led to a 3.14% decrease in quantity. Which one led to a bigger reaction? The 3, right? Just like what you were saying. The 3 shows a bigger responsiveness to a given price change. Okay? So that's this elasticity. Now that's all along a single demand curve. So how we write that is that in between here, the elasticity of demand at this point was equal to negative 1.64. And demand is less elastic. Demand is less elastic at that price. Okay, questions so far? I'm going to write out that interpretation. So let's put interpret. Maybe I'll write it right here. Interpret elasticity of demand equal to negative 3.14. And the importance of this is especially true in MBA class. You guys will not be able to regurgitate this number, this formula, a year from now. Probably not an hour from now, but that's another story, right? But you don't need to, but you should be able to kind of look up and remember the concept of elasticity. And the interpretation here if you're getting paid 6 figures as a consultant, and you go to the CEO, the president of the company, and say, well, we determined that the elasticity was negative 3.14. He's going to say, wah, 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 talk to me in terms of real business, right? Because that's not real business. That's a calculation that has an important meaning, but we got to be able to interpret it. And that interpretation that you need to tell your boss is that a 1% increase in price will lead to a 3.14% decrease in quantity demanded. And then for the boss, you could get a little loose and say in demand. You might even say sales, by the way, to really, this is really quantity sold, right? That's what the boss wants to know. Are we going to sell a product or not? So that is our interpretation. And we get that by just remembering we can put any number over 1, and then you're going back to the most general formula where it's the ratio of the percentage changes. This interpretation just follows off the lips of that setup. All right. I drew this lone soldier over here just to kind of show another variation of this elasticity game. And that is this. If this is a 20-cent change, I drew them side by side so that this would be $1.20, and then we bring our dollar over here. And if the units were being measured similarly, we don't get much of a quantity change, right? So my Q1 and my Q2 is very little. Remember, this is a different demand curve, so I'm free to make up new numbers here. Maybe this is 180 and this is 190. Right? So very little change. Which one of these two demand curves is sticker bars? Which one's cocaine? The one to the left or the one to the right is cocaine? The one to the left or the one to the right is cocaine?
I guess you already said that is the right one, sticker bar.
No, I'm throwing that sticker bar example out the window. So the one to the left, this one's cocaine? Okay, why do you say that?
Because even though the price is dropping, the demand is still going to stay relatively larger than the other.
So cocaine might be a better example to talk about the other direction of raising the price. And remember, it doesn't matter. If I raise the price, you guys go through all these calculations, it's still going to be 3.14, right? Remember, that's what we started off with. So let's talk about raising cocaine from $1 to $1.20. Which demand curve better reflects cocaine? The one on the left or the one to the right? Nathan says the one to the left. You say the one on the right. How do you say that?
You don't care about the price.
Okay, so you're thinking about the quantity, right? Right. Jack the price up on me? I still need it. I need it. Give it to me. I guess that's heroin. Maybe I should be a heroin. All right, so we got cocaine, heroin, other illicit drugs. This demand curve is kind of unresponsive, right? If we go back to our language, a change in price doesn't matter. People aren't responding to price changes. And so this demand curve is relatively inelastic. This one is relatively elastic. So that elastic word kind of goes with responsive. If you've got unresponsive, it's kind of inelastic. It's kind of tight, right? You can kind of think of it that way. So this demand curve, steep demand, means it is relatively inelastic or unresponsive. Unresponsive to price changes, if you want to think of it that way. All right, I got one more picture. I know this is kind of going a little bit later, but I want to wrap this up with this last thing. Any questions there while I'm erasing? I think I'm going to get rid of this. I want to bring you back to fitting this in with total revenue. Oh, I wanted to tell you one other trick. When you look at this, as the demand curve starts to get steeper and steeper, if I take this one and I just start to rotate it, right, it starts to look more and more like a I or inelastic. That's a little trick that I kind of help my brain keep, right? So the steeper the demand curve, the more it starts to look like an I, which is a more inelastic demand curve, okay? All right, so last thing before we take a break. That shouldn't take too long now that we got all this ammunition. This time I want to draw two graphs stacked on top of each other. On the upstairs, we're going to have a demand curve. Go ahead and draw this demand curve so that it goes all the way to the horizontal intercept. It doesn't really matter where you draw it on your paper, but draw it so that it goes down to there. And then on the lower graph, we're going to draw total revenue. So on the vertical axis is TR, which is equal to price times quantity, remember, just like we did last time. So this is total revenue for my company. And then the quantity is on the horizontal axis, and the reason I have them stacked is that if this happens to be at 1,000 units, then it stacks vertically with 1,000 units down here. All right. The elasticity of demand changes along a single demand curve. We calculated two of them here, but it actually ranges between 0 and infinity. Check out what happens when we get way up here. If I go from 1 units to 2 units, Jillian, what kind of percent is that roughly? Forgetting about the averages and all that. I think it was you.
What, the negative?
If I go from 1 unit to 2 units, what's the percentage change in quantity? 100%, right? It's really big. And if I do that up here, the price change is from, let's say, $1.33 to $1.44, or $1.34 is what I meant to say. Maybe it's bigger than that, whatever. How about the percentage change up here? Really, really small, right? So we've got a big upstairs. Where's my formula here? Somewhere here. We've got a big upstairs and a really, really tiny downstairs, right? Which makes this number really, really big, approaching infinity. So numbers are really big for elasticity here. And on the flip side, if we're all the way down, let me go to this one since it's here. Again, $1 to $2 is like 100% change. But the quantities are from 1,000 to 999. Really, really, really tiny. And then that means I've got a small upstairs and a really, really big downstairs, which means it's close to 0. Right? So we got next to nothing there. So the elasticity ranges from the infinity down to 0. Somewhere in between here, the elasticity equals 1. And it always happens at a special point. Wherever on your graph the midpoint is, if you go straight up from there, that's where the elasticity of demand in absolute value is equal to 1. Here, we weren't even quite getting to there yet. We went from 3 to 1.64. Somewhere along there, it equals 1. Over here, in this range, all of the elasticities of demand are greater than 1.
They are called as positive and negative elasticities, right, sir?
I'm sorry, a little bit louder. Say that again.
They are called as the positive elasticity of the demand and the negative elasticity of the demand, right? Hello. Hello.
All right, am I back live?
Yeah.
Okay, sorry. I was trying to make the speaker louder. Say your question again.
Like the term used for the whatever the topic you're telling is like the positive elasticity of the demand. Is it correct?
Greater than 1, not positive. They're all positive in absolute value, but it's greater than 1.
Okay.
Okay? So the absolute value, remember they're all negative, back to that whole story. So in terms of positive, it would be greater than 1. If it's greater than 1, is the upstairs bigger than the downstairs or vice versa? Which one's bigger, upstairs or downstairs? Upstairs. More responsive or less responsive? More. More elastic or less elastic? More. So this is the elastic range. Elastic range of the demand curve. Over here, the elasticity of demand in absolute value is less than 1, which means just the opposite. The downstairs is bigger than the upstairs, which means demand is unresponsive or inelastic. So this is the inelastic range of the demand curve. All right, now for the fun part. I'm going to draw this, and then you guys watch me draw it first, I guess is what I'm saying, and then you can do it. This line is kind of special, and total revenues go up for a while. They max out, and then they come down, and it's kind of a bell-shaped curve. That's what the total revenue function looks like. It goes up for a while, and then it goes down. Remember that they were fighting with each other, right? Sometimes when prices go up, the price effect is smaller than the quantity effect, and the company wins. Revenues go up. So sometimes when price goes, let me go down. When price goes down, we sell more. If the quantity effect is really big, if the up arrow is bigger than the down arrow, then the company's revenues climb, right? However, if we're in the inelastic range of the demand curve, a price decrease will actually cause revenues to fall because the quantity effect is smaller than the price effect. And so total revenues start to fall. All right, so the reason why this graph is kind of handy is that, similar to what we did over there, if I take a price change from point A to point B, prices are falling from A to B, that is going to cause revenues for my company to climb if demand is elastic. I'm going to climb revenue mountain here from point A prime to B prime. Right? See how A and B are connected with each other at these quantities. I'm going to be climbing revenue mountain. So that's good for revenues. Remember, we're ultimately interested in maximizing profits, not revenues, but that's another story we'll get back to. If, however, I do that similar price change from point C to point D, which might be the same price change, I cut prices, but demand was inelastic, I'm going to see money get out of the cash register. And we're going to be falling on revenue mountain from point C prime to point D prime.
So is the elasticity, the like absolute value of 1, is that the break-even point?
It's you can kind of think of it, it's where they equal each other, right? It's the maximization of total revenue. So I can't emphasize this enough. The goal with my company is to maximize profit. So this maximizes revenues, but not necessarily profits. So at that point, what's true about the percentage change in quantity demanded and the percentage change in price? They're the same, yeah. So a 1% increase in price leads to 1% decrease in quantity. They're equal to each other. So right here, if we were to think about a really small change around this point, like if I pick those 2 points, just like what we were doing here, right? That would correspond with 2 points right here. So then you'd go back to your boss and you say, you know what? I don't think it really matters. We're at this point where we've maxed out revenues, and that price change probably isn't worth doing. And this might be a good spot to point out, bringing in a little bit of cost. If I cut price, law of demand tells me I'm going to sell more or less. If I cut price, I'm going to sell more. What happens to my costs? They're going to go up. Why? More, and what type of costs are those? Variable, yes. So unless all of your costs were fixed, then you wouldn't have any cost change, right? But if you've got variable costs, your costs are going to go up. Costs go up, but revenues don't. That's not a good answer, right? That's going to cause profits to fall. So that's why this elasticity decision is real important. Okay, any other questions there? This is like one of my favorite graphs in economics. If you memorize the graph, it tells a whole bunch of stories, right? Because it's like multiple choice question. If demand is inelastic and company raises their price from $10 to $12, what will happen to revenues? And if you have this memorized, you're like, oh, inelastic means you're over here, and if I raise the price, I'll be moving from D to C. I'm actually going to have revenues go up, right? So you can kind of go back and forth with the connecting of the dots, which makes it kind of nice. All right, any other questions there? All right, I look like I wore you guys out here. We better take a break. Take a break, and we'll come back and continue the excitement.
Is there such a thing as a elasticity of demand curve? We're talking about as it approaches infinity in one direction, it approaches 0 in the other direction. Is there like a
what there is, a real demand curve is likely not linear.
Okay.
And so with some curves on there, it's going to look a little bit different. And more of a mathematical thing maybe than anything else is, I'm trying to leave this meeting with this. Okay, leave meeting. Okay. This thing's going to run out of battery already anyway. If you've got a...
Russ.
Yes? I'm answering the question. Hold on 1 sec. I'll come back to you. Hold on. If a demand curve looks like this, which it possibly could, there's some evidence of some demand curves looking like that, it's possible for the elasticity of demand at each one of these points to be the same. That's called a constant elasticity of demand function. So if it's curvy, which a real world demand curve, there's no reason, this is all for simplicity, that we do a linear demand curve.
Right.
Now a linear demand curve might be fine if we're looking between data, if our data points are between here and here, then estimating a linear demand curve might be just fine. You see what I mean? So that assumption isn't necessarily crazy in terms of an analysis if the demand is seeming to be pretty linear over that section. Okay? All right, what was your question?
how you are evaluating the homework problems for us.
The homework problem. So
We're gonna check out for our presentation, like APA format and
did you see the comments that I made on your paper from week 1?
Mm-hmm.
Okay, I made comments on everybody's paper. So if you pull up your paper and look at the document, I made comments on it. So that's where your score came from. So look at that, and then if you have any questions, you can ask me. Okay?
Thank you.
Yep. I'm going to go get some water. Maybe I'll take this back. I'm done with this today.
Actually, Mr. Russ.
Yes?
The guy who made a call to you, it's me.
Yes.
Thing, I have submitted my.
I have your guys' names up there. So Manish, right?
Yeah. Yes, sir. The thing is, I'm looking down for basic notes so that I can understand more clear, because the managerial economics, I used whatever I learned is from the scratch, and it's only like a basic thing, and I'm trying to push myself a lot to get more perfect in the subject, whatever you're telling, because the flow which you are telling is like too much for me to understand.
So did you get the principles textbook?
Not yet, sir, but I'm trying to find it out.
Well, you're at the library. They might have one there.
Yeah.
Maybe on the break, you should go see if they have one there. They might. They might have one. Seriously, go ask the librarian right now and see if maybe you could check it out. Of course, you have to have probably your ID or whatever. But
yeah, I have it, sir.
Yeah. So and there's probably, I don't know what other online resources there might be for principles textbooks, but there might be something close to free on. And if you find something that's kind of free on the internet, you can email me the link and I'll look it over and see if it looks like it would be a good substitute.
Yes, sir. The thing is, I tried, I was fully busy with the work, whatever the homework you gave for us. So I tried to push myself, as I'm a bit back in the interactive quizzes. So it took my almost the week time. I was trying to understand what is the actual principle is, and then after trying to understand the quizzes. So this week you're gonna see my worst performance in the managerial economics.
That's okay. That happens. So I understand. So just keep at it and get those other resources.
Yes, sir.
And we have lots of points left. So just try your best to keep on it early and often.
Yeah, that's why I started doing, instead of doing the 6th and 7th week interactive assignment by next week, I started doing it by today.
Okay, good.
So I don't want to, I want to save the time to make it more interaction in the subject rather than making time waste for the quiz.
Yes, that sounds good.
Yeah, I'm trying to make up a time for it so that I want to improve it more in this subject, because it really means for me. I scored a top in my bachelor's exam for managerial economics and financial accounting, but right now I'm really down because it's been 4 years back where I just had the liability balancing sheets and everything. After that, I never had anything on it.
Yeah, I understand. You're not alone. I know there's other people that are doing the same thing. So,
yes, sir.
Okay, I'm going to go get some water.
You too. Me too, sir. Bye. Okay. Yeah.
Karen, why didn't you come outside?
I don't want to tease myself. I don't want to pretend like I'm free with financial. True.
That might be at 9 o'clock, right, Beth? Probably not. Probably not.
We'll see. We'll see.
You childish.
Sorry. Oh, man. I did it like in 5 minutes.
What do you get? 6 minutes? What are the ones you got?
No one's got a Pikachu, let's be honest. I don't care.
I was driving by from the I-35 yesterday and I saw a Pikachu.
You saw it? Like visually saw it? I think they're invisible. You saw it? Wait, I'm confused. Why were you driving with your phone with your vision? Wait, I'm confused. Why were you driving with your phone with your vision? My life is more important than invisible Pokemon. Just saying. Bad, they do bad. So let me get this straight. You're gonna drive the phone in your face, you're gonna make really don't want to get in a Adidas sweater. Okay, that just is not right.
That's why Pikachu is busy catching Pikachu. Yeah, that's what it is on Facebook.
I like you to do it at all. No.
And the horse right there.
I can see you, but. Well, I did. I can see your eyes.
Why are we looking at it?
My wife actually made.
I got like so hot.
She made everything out just like gone.
See, so it's up, right? Can't see with one. Wow.
Just give me a gift card, all right?
No, but like, I just did it yesterday, actually, so I just like.
Oh my God,
Especially when like, yeah, like 2 o'clock. It's not too long.
Like she goes to restaurants.
All right, so we got lots of fun topics yet to hit here that are related to what we've started with. Let's see, I could, I didn't think about doing this. I might be able to make this computer be my. This computer can catch this side of the board for me. Okay, that might work. My other one died. I had the little iPhone thing. Okay, let's see, where to begin? This is chapter 6, all of this so far. So chapter 7 is going to be a little bit shorter, but we got a few more topics to talk about with number 6. So let's see. How about we talked about other elasticities first. So other elasticities, question mark. So the one we've been working on the whole time is called the price elasticity of demand, or just the general elasticity of demand. But we also have others. One notable one is the income elasticity. And what do you figure that number measures?
Income quantity.
Income and quantity, good. So what was the formula, or not the formula, the definition for the elasticity? A number that measures the responsiveness of quantity demanded to price change. And income elasticity is going to be a number that measures the responsiveness of quantity demanded to a change in
income.
We're going to do that for everything. We're going to continue to put that in for other things too. The formula is the same, except for we're going to divide by the percentage change in income this time. And the story would be similar with the interpretation. So maybe I'll give you an example. If the income elasticity was equal to I don't know, 1.2. We could do that same trick where any number can be divided by 1. And so you'd say to yourself, a 1% increase in income, I'm going to do a little shorthand notation now, a 1% increase in income leads to a 1.2% decrease in quantity or increase? Increase. For sure?
Yes.
Always?
No.
Okay. So which one would be a decrease, which one would be an increase? So income goes up. Do I typically buy more stuff or less?
More stuff.
Typically more. What do economists call that good? A normal good. Remember that lingo from the start of the hour here, 2 hours ago, I guess now. So an increase in income leads to an increase in more purchases for normal goods, but if it's ramen noodles, right, Michael? Increase in income leads to a decrease, which would be a negative number here. So the sign here does matter. With the price elasticity, it was always negative, so since it's always negative, sometimes we talk about it as a positive, and everybody knows that. Here, sign matters, not size. Size may matter too, but sign matters, right? Sign matters. If it's positive, it's a normal good. If it's negative, it's an inferior good. So this one I have as a positive. I'll just put a little positive, even though we don't usually do that. So that this interpretation is a 1% increase in income leads to a 1.2% increase in quantity demanded. Note, since the elasticity, the income elasticity is greater than 0, since it's a positive number, that implies that the good is a normal good. If it was negative, it would be an inferior good. Okay, questions on that one? All right, another one that's common that we'll kind of come back to is a cross-price elasticity. Cross-price elasticity. And for this one, the formula is the percentage change in the quantity of one good divided by the percentage change in price in another good that's related to it. So your textbook might use a boring 1 and 2 or something. For me, it's just easier to think about the formula. We can just throw in Coke and Pepsi. Right? So 2 different goods. Could be peanut butter and jelly. Does sign matter with the cross-price elasticity?
Hold on, is there a percent change?
Percent change in quantity of Coke divided by the percent change in the price of Pepsi. Oh, did I? Oh, yeah. Thank you.
Okay, so can you say that example again?
Does sign matter is what I was wondering. So in other words, is this always negative? Is this always positive? Does it matter if it's a negative sign or positive sign? In terms of related goods. So if this was Coke and Pepsi, would you expect it to be a negative sign or a positive sign?
If it is positive, then it goes for Coke, and if it is negative, then it's all for Pepsi.
It's got to be the same for both, and I'll explain that in a little bit, but the relationship needs to be one direction or the other, because if they're substitutes or complements, right? So remember doing this, price of Pepsi goes up, quantity demanded of Coke goes up. Pepsi, more expensive. What am I going to buy more of? More Coke or less Coke? Or more Coke? So positive sign or negative sign for those?
It's positive sign.
Yeah. If price falls for Pepsi, then people are going to start buying Pepsi and less Coke. So that sign moves the same direction, whether it's an up direction or a down direction. And so Coke and Pepsi are substitutes. And so that's going to give us a negative sign, right? It's going to be something negative, whatever that number is, and that's going to make a difference. So if it's Coke and Pepsi, that would be a negative relationship for substitutes, and therefore a negative sign. So in general, if the cross-price elasticity is less than 0, if the number is negative, then the goods are substitutes for each other.
So does that mean it's positive than their complements?
Then they're complements, yeah. So if the cross-price elasticity is greater than 0, then the goods are complements. And all of this elasticity business, bear in mind, ties in nicely to the demand curve and the shifters that we started off with today. It's kind of a weird looking C, cross-price. So, you know, sometimes I use examples like Coke and Pepsi or something, but it might not be immediately obvious the relationship of the two goods, and so you might do a study to determine if they're complements or substitutes. So beer and wine, substitutes or complements? Okay, on what?
The household.
Okay, on the household, yeah, so that's going to tie nicely into my next topic, but So it might depend on the household, right? Whether
If she's buying groceries, she wants wine, that's what they have here for the Super Bowl party.
that's right. So you might buy beer and wine together. So if you tend to just have alcohol available at the household, sometimes some nights it's a wine night, some nights it's a beer night, right? You might switch. The two might be complements actually for that particular household, not necessarily substitutes. Now on a given night, if we specify the time frame, one might be a substitute for the other, possibly. So my point with all that is that sometimes it's not immediately obvious from market data on whether how those two goods are related to each other. Because we can calculate this, by the way, with anything. Is this golf club and this water bottle substitutes or complements? Seem like they'd be complements, right? So what's another possibility if they're not a complement and they're not a substitute? Unrelated. What would our elasticity number be? Equal to 0 or close to 0, right? So then we can look to see if it's statistically close enough to 0 to call it 0. And so that's what we do with market data, is gather a whole bunch of sales information on golf clubs and water bottles and run some what we call econometrics, which is economic statistics basically, to see what these relationships are. And the data will kick out numbers for us on that relationship. And so if the number's higher, are they more substitutes with each other or less? So in other words, if this is a bigger number, that's a negative relationship, so -6 versus a -3, is the 6 like they're really substitutes with each other, like more substitutability, or less? Which one, the 6 or the 3?
The higher the number, the more they're related.
The more they're connected, right? The more responsive. Now think about it this way. If you bump price a penny, I'm frickin' buying Coke. I'm going to switch. If you bump Pepsi up by a penny, I'm buying Coke, right? Because in my mind, by the way, I'm not telling you. In my mind, Coke and Pepsi are perfect substitutes. If I think two goods are perfect substitutes, then as soon as you raise the price on one, oh, I go to the other one. I'm very responsive to price changes, right? That would be a bigger number. That would be a bigger response for a given price change. Okay, so that's how we use those numbers, and then, of course, the interpretation would change for our CEO. If it's a 6 versus a 3, a 6 would be a 1% change in Pepsi leads to a 6% decrease in Coke, right? A 3 number would be a 1% change in Pepsi leads to a 3% change in Coke. So the interpretation is different depending on the responsiveness of consumers to that particular good. So how closely related, how good as substitutes they are, plays an impact in people's buying behaviors. All right, any other questions on that one?
Just out of curiosity, Coke, using this example of Coke and Pepsi, I mean, they're, in most people's minds, it's kind of like Ford and Chevy. They actually be very close to each other, not very responsive to each other.
Why don't you tell me that? What do you guys think? What do you observe on the shelves when you go to Walmart between Coke prices and Pepsi prices? About the same. Why? Is that why the prices would be? Does that mean that they're likely close substitutes?
I don't think they're even substitute.
Yeah, they're not.
Well, think about like you go to a restaurant and they say, oh, we have Pepsi products or Coke products.
Yeah.
Before you like ever order, or if you like, oh, I want a Pepsi, and I want this Coke, okay. Most people are gonna say no. They're gonna want something different. But because they ask, like,
so this kind of ties in nicely to my market data, because one of the issues that you're going to find maybe difficult to overcome in this class is setting your personal preferences a little bit aside and to kind of think about the market. So if I think about the market of people as these dashed lines, these are COLA buyers. right? These are cola buyers. What I'm hearing you guys say is that I got my friends, and if it's a Coke, it's a Coke. Gosh darn it, it doesn't matter what the price is. And I've got my friends, and gosh darn it, they're Pepsi. This was just my luck that I grabbed blue and red. If Pepsi's cheaper, it doesn't matter, I'm buying the Pepsi. That's what I'm hearing, the brand loyalty stuff, right? Now, who's this group in the middle?
They don't care.
The ones who do not care. And so, in order to capture those people, what do I need to do? Price. And so that's why we tend to see the prices be similar on the shelves, because these two people are not battling over these people, they got them. They got them addicted to it. It's back to Coca-Cola, cocaine. I talked about this earlier already, right? They got them. It doesn't matter. They don't have to fight for them. They got to fight for these guys. And so these guys dictate the market, because if these guys are a penny cheaper than these guys, then this market grows. They've captured those guys. Of course, these guys know that. So they cut their price, and they cut their price, and so we get this market that meets somewhere in the middle. But the real end result is that the price of a Pepsi and the price of the Coke are basically the same price. And that jumps about 3 weeks ahead into game theory that we'll talk about some of that fun stuff. But that's the idea. And again, we got to separate ourselves from the anecdotal stories of, well, I think the world works this way. There's always Coke lovers and there's always Pepsi lovers. Yes, there is. But it's these middle folks that is where the battle is fought, not on the endpoints, not on the people you got already. Okay? All right. So the last one that I might just put up here, your textbook talks about an advertising elasticity, which is fine, but you can do kind of a anything elasticity. There's kind of an anything elasticity, whatever's relevant to your particular business. Anything that's unique to your particular circumstances, the formula is the same. The percentage change in the sales of your good divided by the percentage change in that anything variable. And that anything variable, as your textbook goes through, could be advertising. How responsive are my sales to my branding, right? Well, I've learned that if I increase my advertising by 10%, then my quantity sold goes up by 3% or 4% or 5%, right? So we're going to quantify that number, which helps us make better decisions. So I just kind of think about this, that it's possible to calculate an elasticity for anything. All right. Questions there? So I'm going to kind of build on this concept slightly just by thinking about the market demand curve. So market demand versus individual demand. I'm just going to draw kind of a quick little, this is really just to motivate a concept. Let's draw four graphs all side by side with each other. And we've got Lindsay, Jillian, and Manish, right? And so each one of you have your own demand for Pepsi this week. And so Lindsay's looks like that, Jillian's looks like that, Manish's looks like this. So all of these are the individual quantities that each person, I'm going to put a little q here just to kind of remember that this is a little q. Of course, there's thousands of people that demand Pepsi, but we're just picking off 3 of them. And then the graph off to the right is the market demand. How does that actually get built? Well, the market demand is really the sum of the individual demands, right? The quantities, big Q that we've been talking about. Is this thing, should I drop this thing? I think I can somehow. Is it in your way or not? A little bit?
Yeah.
Oh, I just get it out of here like that. This one too? Yeah, I guess I don't. Oh no, these guys are using that one. So that one I'll move it around if you can't see so, or feel free to stand up always too. All right, so the big Q that we've been talking about, and I'm serious, like feel free to stand up if you need to see the board, or ask me to. Big Q that we've been talking about is equal to the sum of the little q's, I equal 1 to n. Here's some of that scary math stuff again, but this one's not too bad. Anybody remember using that summation sign, little sigma? Little q's, big Q. If I add up Lindsay, Jillian, and Manish, then I get the big Q. That's all that says, right? So if I equals 3, like it does in this case, then it's Q1 plus Q2 plus Q3, ... plus Qn. You're just simply adding up all of the individual quantities. Now, if the price of the good is, let's see, where are we at here? Let's go back to, well, we're kind of on Pepsi, but let's go back to, give me a good, any good, name it.
Cheez-Its.
Cheez-Its, all right, so we got Cheez-Its. So if Cheez-Its are running $6 a box, how many is Lindsay buying? How much is Jillian buying? Something, right? I haven't given you guys actual numbers. Is Manish in the market at $6? No. So at $6, Lindsay's out of the market. Jillian's in the market at 10 boxes. And so Jillian is the only buyer at 10, right? Now, if we drop down to $4, Lindsay said, I'll eat some of those Cheez-Its. She's in for 5. Jillian's loving it. She bumps it up to 12. Elasticity of demand is a little bit different for everybody, right? Slope of the demand curve kind of makes that happen. 12 plus 5 is 17. Manish is still out of the market. So at a price of 4, the market quantity has jumped to 17.
We have the 5 and 12.
Yep, 5 plus 12.
Yeah.
And then finally, we get down to, I guess I want Lindsay out of the market here. So $3. Lindsay's loving them, very responsive. Now that we got into her ballpark here, she's doubling up. Jillian's still good on them, but only going to bump up to 14. And now Manish is in for 3 also. All right, so now we've got 10 plus 14 is 24, plus 3 is 27. There's now 27 out in the marketplace. And so big Q, the market demand, is the individual sum, right? The sum of the individual demands, I should say. And so that big demand that we draw for the market is always the sum of individual behavior. So your textbook refers to this as aggregate demand, which I kind of don't like that language because it's more usually reserved for macro class, for like GDP and stuff, but that's okay. Aggregate makes sense. Aggregate simply means summing up, and that's what we're really doing, is we're summing up the individual demands to create the market demand. All right, and so again, this is kind of nice, back to consumer surplus. At a price of $3, Lindsay has 10, some of which pay more money. So the consumer surplus that she's getting off that is that triangle for each unit. If we added up each of the individual, remember for each box, she starts to get sick of them. You give me one box, hey, I'm willing to pay a lot for that one box, but the second box, the third box, the fourth box, I have a willingness to pay that is declining. And that's due to a different law that we haven't really talked about much, called the law of diminishing marginal utility. My satisfaction of each additional box falls, therefore I'm willing to pay less. And that's really what creates a downward sloping demand curve. So our own individual behavior is ultimately what creates this market demand that's trying to be satisfied. And the more you understand this going on, the better you'll do next week and the week after, actually it's the week after especially, when we get into more complex pricing. Because then we're going to come up with ways to, hey, well, maybe if I was smart, I'll just sell Jillian $6 boxes, and I'll sell Lindsay $4 boxes. And maybe I can make more money that way, if I can charge different prices to different people. Well, that's just a little foreshadowing. I don't even want to dwell on that too much, but that's kind of where we're going with this, why it's important to think about it. Okay, so any questions on deriving the market demand? Most of the time in a problem, you're just going to be given this, but this has this underlying it. The market demand always has individual behavior underlying it. Okay, last concept for this particular chapter is kind of a neat little thing that could be very useful for companies. Last week we talked about a break-even quantity. Does anybody remember?
Yeah.
The gist of that? Yeah, go ahead. What was it?
Break even.
Yeah, break even. What was the break even?
FC divided by I plus or B minus MC. Yeah.
How about P minus MC? Yeah. So good memory. Or did you pull that off your notes here? Awesome. Okay. Now, tell me the logic of it. The harder part. One thing to memorize the formula, which, by the way, I think is the first step. So I think your first step is awesome. And now, let's interpret that. FC stands for?
Fixed cost.
Fixed cost.
Price minus marginal cost.
And price minus marginal cost, which was called what? Contribution margin. Right. And so somebody here picked up on that variable cost thing. It might have been Samantha, maybe. Right? When we were talking about variable costs. So if we think about our break-even quantity, this is how many units I need to sell to cover my fixed costs. I need to sell this many units to cover my fixed costs. If I sell more, then woohoo, I'm making more money, right? I'm making profit. But to break even, I need to do that. All right, so related to this break-even quantity is a stay-even quantity. This is called the break-even quantity. And this next concept we're going to look at is the stay-even quantity. Kind of a kissing cousin to that. All right, so the stay-even quantity looks like this. So SE, stay-even quantity, SEQ, let's call it, is really a percent change stay-even. How should I put this? I kind of didn't have this written out this way. I was trying to be cutesy with it. Let's call it percent change stay-even quantity. Percent, I suppose I need a change in there. You're going to call me on the delta again. So percent change stay-even quantity. Maybe this isn't quite looking so good anymore, but it's the quantity that, in percentage terms, I need to I'll stay even by if I sell it. So we're just kind of converting it similar to calculating the quantity here. Now we're thinking in percentage change terms. All right, here's what it turns out to be. If we take the percentage change in price over the percentage change in price plus the contribution margin. And by the way, this is a percent too. The contribution margin is a percent. I suppose there's nothing wrong with putting CM percent. So the contribution margin. So the contribution margin is price minus marginal cost over price.
Russ?
Yes?
Could you turn the screen a little bit this side? Because I'm not able to see.
Let me see. Are you on the other
Yeah. Yeah, now it's clear. Now it's clear.
Okay, good.
Thank you.
Okay, so notice the connection here, right? Contribution margin is P minus MC. This is P minus MC divided by P, so we're looking at it as a fraction. It's kind of like a markup. This is another word for this. It's kind of markup percent. So I'm selling my product for $100. I've got marginal cost of 50. 100 minus 50 divided by 100 is a 50% markup, or contribution margin percent. All right. So this thing then tells us the percent that quantities need to change by. The reason this is powerful for business is that they typically know their contribution margin, their markup. So note, businesses usually know, the good ones anyway, the CM percent, the contribution margin or the markup. Let me go ahead and write, I've been saying it, but I haven't wrote it up. This is also called the markup. And if they know that, then they can gut shot the percentage change by using this formula. So check it out. If we're thinking, we know our price, so I should put that down too, and we know our current price that we're selling our product at, right? We know our current price. We're selling these things for $10. We're contemplating a 5% increase in price. We can use this formula then to calculate how much of a quantity effect there'd be to stay even with our, and by the way, this is with profit because we've got marginal costs involved. All right, so let me give you a little quick example that will really drive us home, and then we'll move on. Example. Suppose you've got a contribution margin of 40%, and considering a 5% increase in price. What is the stay even quantity? So with this one, you can keep the decimals in, or you can just keep it as a number. It doesn't actually matter because the ratio will stay the same. And so my stay even quantity is going to be, I'll try to keep consistent with what I got it written over there. My stay even quantity is going to be 5 over 5 plus 40. This is it. It's pretty easy. Just following this. 5 over 5 plus 40 equals 5 over 45. which gives me 11.11. So in order for me to stay even, what are you thinking about in the boardroom with your boss? If I jack prices up 5%, in order to stay even,
You have to sell 11% more.
It's like 0.1%.
careful with that. You're right to think about quantity, but go ahead, somebody online. Is there somebody being helped by the waitress at Starbucks? I hear a female voice. Okay.
It's all about the library closing, sir.
The library. You're getting kicked out of here pretty soon. He's at the library.
They're telling us to get lost from here.
Now, you can join by phone if you have it too, by the way. So, hey, maybe you can sit on the bench outside the library. Their Wi-Fi might stay on.
Yeah, I'm trying to do it that one also, sir.
Right. Well, I have this being recorded, so you can go look later if you have to leave. So if you end up having to go, you just have to check the recording here in a little bit.
Sure, sir.
All right, so back to the quantity. To stay even, what needs to happen? Price goes up by 5%. Quantity goes up or down? Down by the law of demand, right? So see what's going on here is we've got the law of demand at play, where we've got the two things fighting each other. I'm going to ramp up price. Quantity's going to fall. I will stay even as long as that fall isn't more than 11.11%. That way at the boardroom, you can kind of think to yourself, well, you know, I think our customers really want our product, and there's no way that we're going to lose 11% sales. So I think this is a go. Let's do it. If we only lose 7% of our customers, if they're pretty loyal to us, this is a go. Let's do it. Let's raise prices 5%. You see how it kind of changes the nature of the discussion in the boardroom by thinking about this. This all, by the way, stems from a marginal benefit, marginal cost, right where we started at tonight and talked about before. These calculations is kind of a nice little sweet formula that falls out of the elasticity stuff. Again, with kind of some complex math formulas, you end up getting this nice little thing.
Would you say that again? So
Yeah.
raise the price by 5%, quantity, yeah.
Yep, I'm going to write it even because that one's important. All right, so if price rises 5%, we will make money. I'll put it even more plainly. We will make money if quantity does not fall by more than 11.11%.
So if through another analysis, it's projected that you're going to fall 7%, then you'd say, go for it. That would be, but right, you'd have to do some other study that tells you.
And what is that study? You are totally right, Kevin. What is that study? Market metrics, kind of. You can even tie it back to maybe a new word you learned tonight. Like we just talked about it, like maybe even 35 seconds. Elasticity, that's right. So if we know the elasticity, which would be done through market metrics, by the way, so I mean your terminology was right. You know, through market metrics, does our data points look like this? Or does our data points look like this? All of these are purchases and sales at different prices. And that's a demand curve, and that's a demand curve. And we do some econometrics, which is your market metrics type stuff. We collect data, we estimate the demand curve, a couple abracadabras, and poof, an elasticity of demand comes out from our market analysis. And if we use that, we can try to estimate what that price will be. All right, so if the elasticity of demand is equal to 2.5, should we do it? If we did our econometrics, estimated the elasticity of demand to be 2.5, should we do it? Because it's greater than 1, it's elastic. Now, if it's elastic, an increase in price leads to a what increase in revenues?
2.5%.
2.5%. So let's look, okay, so I like your going back to that 2.5%. Let's interpret this number. Remember that if we strip it from its absolute value, it's 2.5 over 1, which is the percentage change in quantity over the percentage change in price. Right? So a 1% increase leads to a 2.5% decrease, all that business. The number itself is 2.5. What's our percentage change in price we're contemplating? 5. So 2.5 negative equals percentage change in quantity over 5. What's the percentage change in quantity going to be according to our market study? Solve that expression for
12.5.
12.5? Yes, 12.5, right? 5 times 2.5? 12.5. Should we do it? No. The elasticity, our market analysis says that a 5% increase is going to cause sales to fall by 12.5. Our stay even analysis told us that they can't fall by more than 11 for it to be profitable, so don't do it. And so Kevin, to kind of come back to your thing with the elasticity, this one has cost involved with it. So it did take into account the cost part of the equation. So this is really profit maximization part of it. Elasticities dealt with just that revenue side. And that's what we needed to know was the quantity impact in reality. And so the quantity impact's too big, it's going to hurt us. So don't do it. So therefore, don't do it. All right, any other comments there? All right, so that's chapter 6. Oops, wait, this is not good. I guess that would work, but it's not at all. Okay. So let's see what we can do here. This isn't going to take too long. I got 12 PowerPoint to go through. And that includes the cover page, which doesn't really count. So 11. Piece of cake. What should that take us? Only, what, 10 minutes or something?
I think we should challenge both.
All right, we'll see what I can do here. All right, so we're going to talk a little bit more on the cost side for the last little wrap up here. We talked about this last time, so this is kind of a review. I kind of jumped it a little bit ahead. The law of diminishing marginal product, returns, same thing. So you kind of use those two interchangeably. The law of diminishing marginal product and the law of diminishing returns. Remember, that was my hamburger thing. So if I add another worker, one person can do 100 hamburgers. Eventually, as I add more and more workers, the productivity, the number of hamburgers per worker will fall at the margin. Each incremental worker can't do it as well. And that led to our cost curve looking a little different. So we had the J-shaped marginal cost curve and the average cost curve cutting through the middle. We had the bowl-shaped, if you remember some of that. All right. So here's the picture of the cost curve that we did before. The law of those hamburgers going up, remember my hamburger cost was going up from $1.20 to $1.60 and it was going up. That's this part of the curve, right? So the output was the hamburgers, the cost per unit was going up. That was due to the law of diminishing returns. Average total cost and marginal cost, we cut through the minimum. When the marginal hamburger is cheaper than the average one, it's pulling the average down. Your GPA is falling when you went drinking, right? So your semester GPA was lower than your current overall, which brought your overall down. When your semester GPA equaled your overall GPA, it stayed the same. And then finally, when you got straight A's, your marginal grades were higher than your overall average, so it started pulling the average up. That was our relationship between averages and marginal. That's super important. Economists stay at the margin. Decisions are made at the margin. Poor managers operate on averages. And you guys are going to see that. Most don't think that way. This is what you're going to bring to your company. You're going to say, I think a little differently. I guarantee you, you guys are going to be in some sort of meeting. And your boss is going to say, well, the average of the wage or the average price of the product or the average this is this today. You're going to hear that come out. And hopefully that will send a little bell off in your mind like, what was that thing about marginal? And hopefully you can kind of at least think about that issue, that the incremental worker is going to be different than the average worker. The productivity of that incremental worker or that incremental hamburger might be different. All right, so the focus of this chapter is to think about what we call economies of scale. And the author here highlights the idea of learning curves. So what does a learning curve mean to you? If you're on the learning curve, what does that mean? Takes you a little time, right? So how much hours is it going to take you when you first start versus after you've been there for 3 months? Takes you more time early, right? So you got that learning curve. Well, from a company standpoint, have you ever heard that turnover hurts companies, right? Some of your business classes, maybe other stuff, they want to eliminate turnover. That's because turnover is expensive. Because you bring in a new employee and they've got that learning curve, right? So hours that person spends at their desk is more expensive to me as a company because they're not very productive. They're not getting a lot done today because they're just learning, right? So we've got that learning curve concept going on here, kind of at a larger level. So it can be due to learning, but it can also be due to being able to purchase things in bulk, maybe, or some other concepts that drive the more general concept of economies of scale. All right, so as we build airplanes, notice that our cost of each additional airplane is falling quite a bit. right? So part of that's driven by maybe a large amount of fixed costs involved with airplane manufacturing, and the fact that there isn't a huge market. You can't get up to volume very fast. And so you might be in this learning curve area for a long period of time for your manufacturing process. And if we're in that area, notice that your average costs are falling all the way. We don't have the U shape because we're not at the U, right? We're at the early units before the U turned up on that slide that I had up before. So average costs are falling over all the production area. So the more you make, the cheaper they are. You could think about that being the more aggressive I could be on price, or the more money I can make if I can sell them more because I can do them cheaper. Each one on average is a little cheaper. All right, questions or comments so far on that? A little bit of review sprinkled in with a little bit of a new twist. So our cost curves just simply look like this. The marginal cost is below it, but if this screen continued on to the right, eventually we'd get here, and eventually it would cut through, and it would go up here. But these quantities are kind of irrelevant, right? Because we're never going to sell this many airplanes. We're only going to sell this amount. So we have this economies of scale going on over the whole production range. All right. Got any guitar players? No guitar players? How about online? Oh, I see Roshan, you're a guitar player? All right, so we got a couple of guitar players. So this one's got these fingerboards for guitar. All right, the fingerboard where you put your finger, that little board that comes up. All right, so rosewood's used for cheap guitars, ebony for high-end guitars. Some of them have these blemishes, but it's still better than the rosewood. So imagine you're manufacturing guitars, right? And you've got the blemished ebony fingerboards and the perfect ones. We've got kind of two products almost. So we're already starting to delve into multi-product talk. And this type of formula starts to go away. How many single product companies can you think of even? Single product companies, companies that only make one thing and one thing only. That's what they make. Kind of this big manufacturing, they crank them off the assembly line.
No variation.
No variation. Hard to think of, right? So a lot of what we talk about in class is kind of not real. But we got to start somewhere with baby steps, right? So we start with what's called a single product line, where it's literally identical units being produced, kind of that manufacturing image. But in reality, that just doesn't happen at a lot of businesses. By the way, there are some businesses that might still just focus in on a single product because they found that to be advantageous over the years. But most kind of start to do little variations, some bigger, some smaller. And so when we start doing multi-product lines, this whole marginal cost business becomes a little more complex. What is the cost of the blemished ebony? Almost nothing, right? So it's like we get something in terms of the cost of producing it, and I don't know the full production process, but let's say we don't even know that it's going to be blemished until we make it, right? We start with some big hunk of material, and ultimately we can get a lot of pure product out of it, but some end up being blemished, might be the production process, right? So we don't really know, but if there's no market for that, those would be garbage. And so the flip side of that is to say, if they're garbage, well, wait a second. Somebody might pay a little bit of something. We've got a pretty expensive guitar. Maybe we, and so that's where we start to get a little creative on how we might have multiple products. When companies have multiple products, they're trying to take advantage of what economists call economies of scope. Economies of scale is that single product concept. I make airplanes. Every airplane's identical. As I make more airplanes, the cost of each airplane on average is falling, right? Economies of scale. Make more scale, make more quantity, and I'll be able to lower my costs. Economies of scope is to say, let's make more products. By making more products, using my resources that I've got, I can have total costs that are less. And there's going to be one other slide that kind of shows that, and you guys will have these too, of course. So, suppose we've got a small family-owned company, makes, sells, distributes popular breakfast sausage. Can this firm realize economies of scope? Makes, sells, and distributes. So we got a manufacturing operation, right? They got this breakfast sausage. It's the bomb. How could they take advantage of economies of scope? Got it?
Patties versus links.
Patties and links might be an easy one, right? So I might have to buy another machine. I might have to add a machine. I might have to train my employees to roll them instead of patting them or something, right? So there's going to be costs, but if I look at the cost involved with running a patty operation starting from scratch and running a link operation starting from scratch, that's going to be more costly to run two different plants as opposed to running production together in the same plant, right? That's what economies of scope is. All right, so in formula terms, the cost of joint production, Q1 and Q2, so this is kind of a cost function in kind of a generic form that you might see in the textbook. The cost of joint production is less than the sum of each one being individually produced, kind of in its own plant. That's economies of scope. We're able to leverage maybe some of the machines. I'm able to leverage some of my labor. I'm able to leverage other things, other resources in the production process. Okay, questions or comments there?
No.
All right, thank you. Glad to hear some verbal. I try to watch the screen, but especially when I'm doing the screen share, I don't even see everybody's head up there. So that's good. All right. So other scope economies for companies that you work for with? You guys got any real world stories of economies of scope? And think about, well, why did they do two products, or kind of the advantages of that?
Like restaurant industry, typically you'll do like a special thing, steak, and then the next morning it's like steak and eggs.
Okay, yeah, right. And that's kind of using those leftovers potentially for some of that, right? Okay, so there could be some of that going on. All right, good. So kind of an efficient use of what would otherwise be garbage potentially, right?
Oh.
And a way to tell that, let me just add on, and then I'll come to you, Roshan. Is that you raising your hand? Maybe you never served breakfast before, right? And so you're like, oh, maybe we should start doing breakfast. Subway started doing breakfast, which, by the way, is a whole different story. It kind of failed multiple different locations and all. But adding on a breakfast for that reason would be a good example of scope economies. Okay, go ahead.
You asked a real world example of economics of scope. I have an experience in that in Honda. We were manufacturing a crankcase for an engine. So we had two separate companies which manufactures the two parts. That was when we saw the cost. it was too high for us for the purchase. And when we checked out stats, then we thought the company itself will start manufacturing the two components together, and that brought us an like the production rates were less. So
good example, and that's kind of interesting that your company was the purchaser from them and said, hey, it's like you're almost telling them how to run your business, but basically they're saying, hey, I'm your biggest buyer, start doing it this way, and maybe we'll both make more money, right? You can lower your cost, and I'll make money, you'll make money, you know, and sell more products. So yeah, that's a great example. Yep.
People in the United States, Easton. Most people know Easton makes aluminum bats.
Yep.
But Easton also makes aluminum arrows. They have contacts to get that.
Okay, yeah, with your archery stuff. Cool. Yeah, good example. So, all right, so let's move on here. So, pet food company has 2,500 products with 200 different formulas. This is a true story, right? And I can believe it. I've just started buying Hill's Science Diet for my stupid dog who's got some sort of allergy thing. She's really sweet. She's not stupid. Actually, she's very smart. But I'm saying she's stupid because these bags of frickin' dog food are $95 compared to $50 or $40 at Walmart. So anyway, we love her, and so I don't mind spending the extra money on all the love that I get from my dog. But okay, so what I learned is that they have all these crazy formulas, right? They have, you know, all across the board. So this doesn't shock me at all. All right, so what sort of cost does this have? So you might have heard of Walmart beating up on some of their suppliers to try to get their prices down. And they're like, hey, we're going to go to this guy, you know, kind of similar to what Rashawn's example with Honda, you know, Walmart's saying, I'm going to go to this guy if you can't cut your prices. You know, you got to get them down, and they've been known to beat up prices. So this company had to rethink the idea of economies of scope. So they needed to come up with lower cost dog food. And so an interesting balance was how they did that. By analyzing their production runs, they had the setup time to switch over to the new formulas. You know, they might have to clean out the machines that make dog food that's hypersensitive. I'm thinking of this Hill Science Diet stuff, because I think they're really careful to make sure different products don't get into certain dog food, right? So you imagine they got to scrub the machines, and they got to set up some new controls or whatever. So you got setup time production. And so if the market is there for a wide variety of dog food, they might make more money doing that. So economies of scope might exist. But in the Walmart example, scale economies might have trumped. In other words, they're holding a golden ticket from Walmart. If they reduce that, they'll get into that market range where average costs are lower because they're a guaranteed buyer. And so they reduce the setup time, they crank out a whole bunch of fewer varieties, and overall, they were able to bring their costs down. So they actually got rid of some of their product line and focused in on one. So that depended on the market, right? So they responded to different market pressures. If they were facing the general world without Walmart in there, maybe they were better off having lots of different varieties. But now that they had this single buyer, maybe it was good to hook up with them. Okay, questions or comments on that? All right. Last little bit here. So not trying to throw any punches here, right? We talked about the cost going down. So the first unit, the second unit, so we're talking about marginal cost, right? Remember, we've got the and the third and the, right? So all of those are the cost per unit as we go. if we have a potential project where somebody's willing to buy 4 units, what is my break-even price? $64 is the first one. 32. So we got 64 plus 32 is what, 96. 96 plus 21. 117. And then plus 16, 133. All right, 133. And then to find the price that we break even by, what would I need to do? It's $133 total cost here. Divide that by 4, right? So 133 divided by 4, what does that equal? Just got a calculator handy here.
33 point.
33 point something. Good. All right. So we got 33 bucks into it. We take the 4 unit deal. What if we get somebody looking for 2 more units? What's the break-even price on those 2 units after we've already produced 4?
It depends on 2 types, sir. Like whether he's adding on the 4, he's adding the 2 units to 4, or like he's taking the 2 units new.
Yes, he's adding. So we've already produced the first 4, and now we've picked up another deal from a different person. What's my break-even price for those additional 2?
It's at 48.
We got the 5th and the 6th.
Oh, then it's like 24, 12.
4 divided by.
It's 12.
It's 12, right? 22 units. Those extra 2 units cost me 13 plus 11 is 24 bucks. 24 divided by 2. So what's kind of interesting here is that my break-even price is dramatically less, right? And part of that falls into place with my marginal cost thinking. My boss says, hey, I got somebody on the line, and they're looking to do another deal. You know, what price do you think we should go? Well, the average price before was 33 bucks. Let's do 33. Well, I told them 33, and they said, forget it. Well, we're not going to make money if we don't make 33. That might be the boss's answer. Boss's answer is wrong, right? You only need $12 on those last 2 units to break even. The average cost might still be closer to 30, but truly the break even on those additional marginal units is only 12. So you could price them as low as 12 and still break even. That's marginal thinking, right? That's what separates economics from some other things. Now, if the deal was for 6, the break even would be 26. So kind of the story we've kind of come back to a couple times tonight has been, it depends what our starting place is, right? It depends on the circumstances. So we got to say, do I take that step to the right, or do I not take that step to the right? If I take that step to the right, what are the costs involved with that step to the right? In this case, the step to the right was 2 additional units. It only cost me 24 bucks. On average, that would be 12 bucks a unit, right? However, if my step to the right is all 6 units, my answer is different. All 6 units are going to run me on average $26 a unit. So I need to throw out a different price under those circumstances. And now you start to see why some companies are in a position to make you a deal sometimes. Why you can negotiate, because they are truly facing sometimes circumstances that you're unaware of. And it still might be a win-win situation, even at a low price. All right, so I promised we'd get done early tonight, and I'm going to do it. We're done early. Let's call it a night there. Mark your calendars. Done. See, I didn't want to, I had to prove Jasmine wrong. Boy, you guys didn't have any clue. You probably thought it was 8:45. We're having so much fun, so that's all right. All right, good night, all.
Good night, sir.
Good night, Russ.
Good night.
Russ,
Yes.
All right, good night, Russ.
go tell them. And I'll fly next Thursday.
Good night, Russ.
Okay, good night. So let's see.
Good night, Nidish.
Why don't
Turn off.
let's see. So you're here. When are you leaving? Okay, why don't you find that out and email me so that I can respond to that, and then we'll figure out a plan. Yeah, when are you guys? You leave Thursday. When?
Like 2 o'clock.
Okay, that might be some potential. Because I'm back Thursday morning at some point, so maybe there'd be something there. Otherwise, we'll probably try to structure something after. So both of you email me individually, so I got that to respond back to.
Thank you.
Okay, night. Did somebody have a question still online or not?
No, sir, we are done. I think Ma'am Deborah will be having some questions.
Okay, good night.
Yeah, good night.